Hey everybody, welcome to today's live trading stream. I'm Ian Shadden, this is Richard Hinckley. Today we're going to be doing some fun code stuff.
Yep.
And I mean, we're already getting some really solid questions on the forums. And we're going to, I believe, answer these right at the start.
Hopefully.
I think in just on our conversation, because it's actually a really beefy question here that covers a large aspect of what we're going to be rolling over. So I think without much ado, we're going to kind of jump into it. We've already set up our project, mainly because Visual Studio takes a chunk of time to figure this out.
Well, Visual Assist.
Visual Assist sits there and like grinds away, has to find all these project files, or pardon, all these C++ files to load them up and includes and whatever. We've already done that on the side, but for our project, it's a blank C++ with no starter content.
Yeah, it's the most vanilla thing we could do here.
Yep.
And we just did that in advance so we didn't have to wait through it.
Right, because it literally, we started at like 2:30, and it's been done for about 5 minutes. So just getting that out of the way. And besides that, we're totally vanilla at this point.
So yeah, this is just what you get when you start up here. All right, so the question, I guess you just go.
Well, I mean,
there.
He's asked everything that we're going to explain like right at the beginning here.
So
right.
So basically the question is about plugins and what they know or don't know about. So it says a plugin can't know anything about your game or vice versa. Well, the game can know about the plugin, but the plugin can't know about the game. So that part's correct. So it says that it's in our documentation, it's not recommended to have plugins depend on each other. I'm not even sure if it's allowed to have plugins depend on each other.
Wouldn't know, but it does seem kind of awkward.
Yeah.
Like you would have to have a plugin that requires a plugin, but wouldn't that mean the other plugin requires that plugin?
I don't.
So
I don't know. I mean, it's basically supposed to be, engine plugin game, not engine plugin another plugin game.
Right.
I guess technically you could just include some other plugins H file, but then if they don't include that, I mean.
Well, what happens if one plugin changes versus the other plugin, and then functionality is added, removed? So
anyway, I mean, it's not unreasonable to suggest that you could have a stack of multiple plugins that depend on each other, but it's not the way that this engine is meant to be used. So we just kind of don't do it. It's just really an engine level design choice that was made. Maybe UE5 will support that. I don't know, but for now we haven't yet run into a case where you really need to do that.
Right.
We could come up with one. I mean, I could contrive one in a second. That's no problem. But
just as quickly as you contrive one to do it, we could easily contrive reasons why you wouldn't do that.
Yeah, or a pretty simple solution to it where it's not necessary anymore.
Right.
So
but also so we've already stated that we're going to be doing that's a funny question.
Right.
but we're not getting there because the rest of this question is also or no, that's it. No, that's basically plug in for the game. Actually, since we're going to be going through it, we're going to show you how we're going to handle the situation where the plugin will get information from the game or be provided information from the game, I guess is probably a better, more accurate representation.
We could say it that way.
Either way, right? And how it then gives information back.
And
so
I mean, and the game can know about plugins to the extent that you can even extend classes, override virtual functions, make blueprints out of classes that were defined in your plugin.
Right.
So
yeah, this should be all right.
So there are things we can do.
To answer, for whatever reason, this funny question is what screen size do you guys use and how far away is it? I think I'm sitting maybe 7 feet away from, what are these, 50s? 40s? They're 40s? 40-inch widescreen? So,
yep.
And don't worry, when we get into Visual Studio, we'll make sure to set up that we zoom in on the text and everything, because I know a lot of this stuff is really, really tiny.
So you can see we're using 413 here, and what we're about to do, you need 413 for.
Okay.
This is actually new. I checked; it's not in 412.5.
Oh.
So we're going to add a plugin.
Okay.
That's where we're starting out today. So plugins.
Wrong screen.
Over here. All right. So I love Paper 2D. Happens to be the first one, but I'm always happy to see it. New plugin right down here.
Right. Oh,
there we go.
Okay. Right in the corner. Okay.
Pretty simple. Blank. We don't really. I mean, well, like we're not creating a toolbar button. We're not creating a standalone window. This isn't like a user interface kind of thing. Can they see that? They can see that.
Oh, they can see it, but scroll down. There's more.
Yeah.
Blueprint library, editor mode, third-party plugin.
Yeah.
Right.
I just want to create a couple of classes for our game. So nothing really fancy, just that.
It's creating the right location. It's stream stuff, and it's adding it into plugins.
Yeah, D stream stuff. So plugin development is the name of this project. Oh yeah, I wanted to talk about why I named it something so odd. So I named it plugin development because we could possibly make multiple plugins within the same project. Part of the point of the plugin is that we could export this. So this state machine thing we're going to make today, we could just wholesale take that out and put it in another project and use it that way. So we could use this as like a dummy project, sort of, where we develop all these things and then just ship them out to other projects, and this could just be our plugin development thing. We're just going to do everything in here today because that's just an extra step that wastes stream time. Right. But it's super easy to do. You literally just copy it over and then it's there.
I mean, if it's simply just a copy and paste, I mean.
Yeah, there's just no reason to show it, but it's very easy. And the plugin name is going to be State Machine.
Very tiny, but yep.
You can guess by the way I'm leaning that it's a little further than my visual distance at this resolution. All right, so do it. Oh, and where was our document?
Over to.
We need to be here. And let me show you what just everything's going to be popping up on the other screen, so I got to drag it over. So, come here. There we go. Okay, restart the editor because you just created a new plugin, so we can do that. I think before we do that, I'd like to do a couple little things. We could do it. I just okay. So Visual Studio has noticed a project change. Okay, whatever. Yes, reload it. We didn't do anything in here, so just reload whatever the engine just made for us. And plugins, State Machine, source code, State Machine. So the reason that it's repeated like that is that you can have multiple modules within a plugin. Our plugin isn't going to have multiple modules. It's only going to have just the one. And the module name is the same name as the plugin name. So that's why it's State Machine, source code, State Machine. Okay. And then the actual source code's in here. Here and here. So that's why that is. Paper 2D, for example, has a bunch of different modules in it.
And one of them is called Paper 2D.
And one of them is called Paper 2D, yeah.
All
right. So friendly name, State Machine for games. I don't know. This could be whatever.
And we are currently in the State Machine plugin.
Yeah, a bunch of this, by the way, can be edited in the engine. I don't need to do this in this text file. I'm just doing it here. The one thing that you do here, I want this to be a runtime module. And the reason is there are a couple different types of modules. A runtime one will exist in a shipping build. A developer one will be in the editor and in development builds, but not in the final shipping build. So if you put a game out, just remember to change that to runtime, and that's pretty much all you need to do.
Sweet.
And I don't know, just while I'm here, I mean, I'm already here. I'll show where the screen is, and we'll put our company name and stuff like that there, but I just felt like doing that here. So that's pretty good. Okay, so really the only thing that I needed to come in here for was this. And then we can hit restart. So we go back over here.
Restart now.
Hit that restart button that we just talked about. Okay, and then still got to drag it over. And then, okay, so it's going to notice that.
Okay, and we just have to rebuild. Starting a build, and of course, this should be actually really, really quick.
Yeah, this is
there's
not
nothing
too bad.
in there.
6 seconds.
So, yeah.
And now we're starting back up again on the other screen. I can't drag this window over. All right, there we go. So there you go. Now we're started up. Oh, and actually, a thing we can do just to make sure that we got that right. So, like, first thing, let's just check that we actually loaded that at all. We'll go into statemachine.cpp. This code will execute after your module is loaded into memory. Okay, great. So,
gonna drop something into the log.
Yep. Just really quickly, gonna make sure that, let's see, state machine module loaded. Yay. I'm not gonna do anything on shutdown because I don't care. I just need to see the start, and I wouldn't see this anyway because, of course. Now, since it loaded on startup, I'm not going to see this now because it's already loaded. So I'm going to have to close the engine just to do this. we could have done this before hitting the restart button.
And just right quick, you hit Control F5 to relaunch the editor real quick.
Yes, I did.
I'm sure this has been gone over on a number of other C++ streams, but Control F5 being your friend in these cases.
Yep, it's in the debug menu here. Whoops, let me just show that again. It's more of a Visual Studio thing, but it's in the debug menu. Start debugging here, start without debugging. So I want to run the thing, but I don't need to be attached. I'm not going to do any breakpoints or anything, so
but
whatever.
Our project goes ahead and loads the editor and loads everything into it and rebuilds if necessary.
So that loaded up. We scroll up. And right there.
There it is. Yep,
that's why I use
text.
warning, because it's yellow. I can just easily pick that out. Okay, so we got that. All right, so now we have a plugin that is technically
it's loaded and it works.
That was like that would have been like 10 seconds if we hadn't been
and
talking.
we're done. No, I'm kidding.
All right, see you next time. All right.
All right, time to get into the. So there's a bit of functionality that we have to work into here. This is a bit awkward, but it's just kind of the way this works. We're going to step you guys through it so that you can see this in action, but it's going to seem awkward, but trust us, this is the way that it works.
Yeah, I actually learned this by looking at the cable. I think it was it was the foot IK component in platformer game.
Right.
Which Lauren recalled was a runtime module.
It was a runtime module plugin.
Good memory, Lauren. All right, so this is just going to be a dummy object class. We're not going to do anything with this. And this is the cool thing. This is the thing that was added right here.
Oh, okay.
That I can do that. So before you could do other modules, but plugins wouldn't show up here. But in 4.13, plugins show up. Now, a neat thing you'll see here is that it puts you down into the source for State Machine. So now if you look at these two paths right here, this is public, this is private, and it has public clicked. I can click private, this is still private. So the CPP files are always in private.
Right.
They're not going to be seen by whatever includes your module. So this can be public, or it can be classes. And watch when I type the last letter of classes. That becomes
fancy.
Private. So public and classes are the two special folder names that we're going to use here.
Okay.
And I'm just going to check something really quick. I just want to see which one I did before. Where'd that go?
Behind everything. It's not maximized.
There it is. Just a really quick check here before we move along. Source, state machine. Yeah, I did put it in classes when I did this originally. Okay, I don't think it matters. I just want to be consistent. So we're going to create this this dummy object.
Okay.
Again, we're not going to do anything with it.
Compile failed.
Compile failed. Uh-oh. So, yeah, I'd like to see more details about that. Show me that log. Let's dock that here. So,
all source files in module state machine must include the same precompiled header first.
Right.
Okay.
So this, whoops, that's the wrong one. Bring this one back. Okay. So, where are we? Here we are. Okay, so first off, we don't even need this CPP file. So we're going to get rid of this, because there's going to be no implementation for this class. It's a total dummy class. Doesn't even have a C++ file.
Okay. So we're just going to straight up shift delete this out of in Explorer.
In Windows Explorer, dummyobject.cpp. We're not showing extensions for some reason, but whatever. Gone.
Bye.
Bye-bye. And also, don't need it in here.
Okay.
That way we don't have to rebuild the whole thing. Okay, so this is just a totally empty class.
Which is what we want.
Yes. Also, whoops. Also, we don't want to export this class.
Okay.
We have no use for it. So we take off the API tag. So this tag, by the way, this basically says stuff outside of State Machine that uses our State Machine plugin can see this.
Okay.
So if we want any kind of internal classes, anything that there's no reason anyone should ever look at, take that tag off it.
So it's not going to show up anywhere. It's just going to sit here as a dead file.
But if we create a new tag, we put or a new class that we want other people to see, extend, whatever, do that.
And that would be, it could be Well, in this case, it's statemachine.api because it's the name of the plugin.
Yes.
Okay.
And let me see. I don't know if we need to change this. I usually make this engine.h, but yeah, let's just add that just in case. I don't think I actually need to do this, but I usually do. Okay, so we're going to include engine.h. Again, I don't really think that's necessary. Oh wait.
This is the PCH.
I'm not where I meant to be. Yes, this is where it's needed. So there. And I think that's...
we swapped to state machine private
yes.
or pch.h.
Right, so this is the precompiled header include file that was made for us. Okay.
And now hopefully we can compile.
Yes, Control-Shift-B over here. So that should compile just fine now.
Crossing fingers.
Hope so. There you go. And
yeah,
that's not quite done yet. But or is that done? No, I don't think it's done yet.
It hasn't said complete yet.
It's a little hard to say.
But you included engine.h, right? So this might take a little bit longer than before.
So that should be fine. Yeah, that will add time to it.
Right. So, while it's doing that.
There we go. Done.
Succeeded. Yay!
Very good. So now let's get back here and okay, now let's start doing our real stuff because that's the stuff we had to go through so we can add source files.
Again, it's just
done.
It's just a weird kind of loop thing that you got to do. With that done, everything else will work going forward.
Yes.
So and then we can just kind of work as we would normally work in C++.
Yes, and just in case anything unusual happens, I'll just spend one more minute on this. Here's what that did for us. We come up here, state machine. Whoops, all the way back up top. Intermediate, build, Win64. You just keep going. Down the inc path, we will have. Yep, we have this. This lists all our classes in a row. I think it has to be the first one. The first one just has to be our dummy object that has nothing in it. It's it just helps UHT to see what we're doing. It goes through one dummy file, and then after that it works on all the other files. Otherwise, UHT there's a bug in it that we're probably going to address at some point, but right now it's still there that requires this. So that's all we did, and if it doesn't work for you, maybe if you added some files first and then added this, and it's too low on the list, just put your dummy thing first, and I don't know. I've never had to do that manually, but you can.
I mean, yeah, maybe if we have some time, we can test it by, after we make this stuff, we'll make it second in the list. And
and it's an auto-generated file, too, so like it shouldn't even be an issue, but just in case. Okay, enough of that. Now let's go into our next thing. So we're going to make a state machine today.
Okay.
So everything in a state machine is going to be a data asset, pretty much. The state machine is basically just data. It's a graph of nodes that are connected by branches. So that's what we call in computer science a graph. And some of this might be a little computer science 101. Some of it might be 400 level computer science. I don't know. But some of it might be a little bit academic, but there's a point. All right, so we're going to create this new data asset. And I'm going to put it in classes again. There we go, because I like to do that. And we're going to call it, I put the SM underscore, so everything coming out of the state machine module will have this little prefix on the class name.
I was just thinking static meshes.
Static meshes?
Because I'm pretty sure that's what we use as...
Possibly a Metallica fan from 15 years ago. I don't know. But this works pretty well. So this, we're gonna make the state. That's going to be the first thing we're going to start, is just with a state, and then we'll make the branches that connect the states, and then we'll make the conditions and all that sort of thing.
Okay, and was there any reason that we're not using like UObject or anything along those lines? Like, does data asset come with anything special that is really awesome for this, or is it just data asset made sense?
Yeah, data asset's a pretty small class, and I think it just turns off some of the features that we don't need.
Okay.
And it's also, data assets are really good just for because you can there's like a special create for them in our editor in the content browser. So they're pretty convenient to create and pretty easy to work with. So that's why I use them. Oh, and before we forget, it is in the plugin.
Yep.
Now let's see. Oh, good. And it
kept
preserved classes. I've never actually done that in that order before, but good. All right.
Rock on.
Create that class. All right. No big deal. No big deal. We're showing the log. Okay, so this does happen too. This one's actually really easy to fix, and it tells you this error message is exactly correct.
All source file and monitor state machine must include the same precompiled header first.
Yep. So if we go back to our thing over here, it's already reloaded for us. I guess it didn't ask us if we wanted to reload.
No, because I think you're just adding files that will ask if you change.
So normally this would be the correct name for the H file if we added something to the main project. But I remember we had that private PCH file.
Yep.
That's what we actually need to open for plugins. So when you first add a class to this, it will do that. Then after that, it's fine.
Then just build. All right.
Yeah, that's it. I mean, it's not a big thing. I think that's something that I hope we get around to fixing. Actually, I might even look into seeing if I can find some time to fix that myself. But
it seems like a
super easy to get around.
Yeah.
Yeah. I mean, since adding code directly to plugins is new, there turns out to have been a little bump in the road there. Anyway, that's done. And I just want to see that it's compiling. Yeah, it is.
It is currently initializing.
Okay, so let's bring up...
One succeeded, two succeeded. Yay!
Yep. So, I mean, that was it. We literally just had to change that header file.
Okay.
Okay, so we're gonna kind of do this, and with state machines, I find myself working backwards a lot. So we started the file as if we were going to state first, but we're going to kind of start at the other end. So the first thing we're going to do, all right, let's just talk for 1 minute about DFAs and NFAs.
Okay.
So
what is a DFA?
So an FA is a finite automaton.
Okay.
Let's start there. It's a robot that has limits. A DFA is a deterministic finite automaton, and an NFA is a non-deterministic finite automaton.
Okay.
So the difference between these two, anyone casually familiar with the Turing Church thesis from 1936 will know.
Yes, I'm totally familiar. No, please, go on, sir.
The halting problem can't be solved. So basically, if you run any computer program, you can't tell for sure if that computer program is definitely going to finish or if it'll get stuck in some infinite loop. There's actually no way to analyze a computer program and tell that, because any type of analysis you make, any analyzer program you make to look at my program, I can make a program that's custom made to trick your analyzer.
Okay. Why would you do this? But that's fine.
But the point is that theoretically that means that this is now not possible.
Okay.
So the cool thing about, so that's for a Turing machine, which is any computer is a Turing machine. A deterministic finite automata has less capability than a full computer would.
Okay.
And so a DFA will definitely end. So we're going to base most of what we're doing on DFAs. So what a DFA is basically you have nodes and branches connected, and then you have an input string. And so we'll just say that input string is just a bunch of characters, like the letters A through Z, and then each node reads a letter and then goes and then branches and goes to the next one. And then it reads the next letter and branches and goes to the next state. And if there's ever a point where a letter doesn't have a branch associated with it, then the machine stops and says, nope, I reject the input you gave me. And if it gets all the way to the end and runs out of letters, then it also says, nope, I reject that input unless the final state that it landed on was marked as acceptance.
Okay.
So we could do this for the dictionary. For example, we could just take strings of words, and then, so if we wanted the word dog, first node branches with D, second node branches with O, third node branches with D, or with G.
Dodd?
Dodd. I can't spell dog. So we get there, and then where that G goes is to an accept state. And it goes, oh, we're out of letters? Okay, so then that was a valid word. But if we put E on the end, my Doge, that is now not a valid word because we don't have any branches out of that. You know, we might not have any branches out of that except state. We might have an S branch out of that except state into another except state. So dogs is a word, but Doge has nowhere to go.
Because it's not in the dictionary.
So it stops.
Or is it in the dictionary?
I think.
Oh man, that'd be really weird. Anyway, let's move on.
Well, yes, I think I have seen the word Doge mentioned. I think I was playing Assassin's Creed 2, and I think the word Doge was mentioned. It might have been an old rank in the Catholic Church or something. I don't know.
Okay.
I don't know. Anyway, okay, so we're gonna start with that concept. Now we're gonna modify it a little bit.
Okay.
So we had only accepted and not accepted. So we're going to make an enumerated, I know it was thrilling, right?
Thrilling.
So we're going to make an enumerated type to describe what happened when a state machine ran. So, state machine completion type. All right, so what happened when we ran that machine that we just ran? Well, it could be not accepted. It could be accepted. We're going to have an explicit rejection state, though.
Okay.
So instead of just having acceptance states that you can land on, we're also going to have rejection states you can land on. And this way we can tell the difference between your input wasn't long enough to get to the end of the machine versus your input is a recognized ending in the machine, but it's a negative instead of a positive.
Right.
Right. And if you want to do a classic DFA, like a standard computer science DFA, not accepted and rejected are treated the same way.
Okay.
We're also going to have one more step. And this is more of a practical concern. This isn't going to come up today, but so I said that DFAs always end, and they always end in, if you give me, you know, a 10-unit long input string, it will end in 10 moves.
Okay.
Like that's it. It can only go 10, and then past that, it either ran out of data, or you ended early by not having a branch, you landed on an acceptance state, or you didn't, but you ran out of input because every time you take a branch, you chunk off one more of your inputs.
Right.
Period. So that'll definitely end. A non-deterministic is a little different, and it's more complex. You can have a branch that doesn't consume any input, and so right there you can think infinite loop, right? Because I can
you just never consume your input.
Two states that go back and forth with non-consuming branches, and you're done. You have an infinite loop. You can also have multiple states with the same input. So if you were walking down a road and it split off to the right and left, a deterministic finite automata with, would just say left or right. But in a non-deterministic one, you could have two roads that go to the left and one road that goes to the right, and then there could be two possibilities. And the non-deterministic one will have to investigate both and see if either one has a possibility for getting to an acceptance state. So in that way, it can kind of, you can see like the combinatorics, like it just sort of spreads out, and it can start getting pretty big. That's why we're not programming that today.
I was about to say, is that a real word?
Yes, that's why we're not doing this. Now, out of steps is going to be something that only comes back from our code. So when we have any of our states and they're tagged as like, is this a final state? We can have, yeah, it's a final acceptance state. It's good if you end here. We can have, we reject, or we can have, this is just a normal state. It's not an acceptance state. We can't have this, though. This means you said, listen, I don't have that much processor time. Only go 5 steps deep. And I went 5 steps deep, and there's still more input, and there's still more states. So I'm just saying, hey, look, I got this far. It's not done, though.
All right.
No state should be tagged like that, though. You can kind of see why. So let's copy over some comments I wrote for these.
And don't forget your uint 8.
Oh, yes. No reason to take 4 bytes for that. Also, if I don't want to use t-enum as byte, I have to tell it the size of the thing, and it can only be uint 8 right now. Any color, as long as it's black. So.
Is it just a Unreal thing that it can only be?
Yeah, we introduced enum classes fairly recently, and so right now, if you don't want to use t-enum as byte, it has to be a uint 8. Otherwise, you could do any size you want and then use t-enum as byte, and it'll be fine.
Okay.
You can also use the old way that we did enums with the namespaces and the enum type under it. But I like this much better. I just think this
It looks clean.
Yeah, it looks cleaner. It's a cool C++ feature. I'm glad the language has it, and I'm glad we're using it. So that's good. All right. So there we go. So that's pretty straightforward. That's how our machine's going to end. Like I said, we're not going top down. We're going bottom up.
Yep.
And that's why. All right. So structs. When we finish a state machine, traditionally you only need to know if it accepted or not. In this case, especially since we can do a partial run through and then come back later, you might want to know what state it ended on, how far through the input you had read by the time you got there, that kind of stuff. So, and also, you know, what the completion code was if it did complete. So because of all that, I'm going to give you a struct to return. This is similar to how, like, we have f hit result for traces and stuff like that. So we're going to have our result struct.
Cool.
So f state machine result. Okay. So what do we need to know? Well, first off, this is going to be exposed and all that, so just unreal it up. And then what properties do we need? Okay, so we need a completion type, which we just made.
Okay.
Easy enough to name. That auto tabbing. All right, so we need that. And by the way, this may be different from what the state says. If we have the out of steps thing, you can't look at the state you ended on because that definitely won't say out of steps. This is the real reason. It's
gotcha.
yeah.
Okay.
So that's why we need this up here. It's not just. It is also a convenience that you don't have to null check the state and then look in that. You don't have to do that, but also it's practical. There's a code reason why we need that. All right. Now we're gonna want the actual state we ended on. And this, I mean, you don't necessarily. Well, you need this if you're going to continue a partial run. If you completed a run, you might not need this, but depending on your game's implementation, you might just want to know.
Right.
And it's extremely easy to return because we'll be running through the state machine at the time, so we just copy a pointer and then we're out. It's not like that's going to cost us any, you know, processor time.
Right.
And then of course same thing with the final position. So we're going to go the index. All of our data input is just going to be an array of inputs. So we're just going to say how far in the array did we get. It's on you, the person outside this, to make sure that you maintain that. If you want to resume later, maintain that. Like you maintain the input that you had. The state machine doesn't store it because that would be the state machine using up memory for this feature. So instead, you maintain it and just don't delete it, or just keep a backup copy if you need it, if you want to resume the machine later. That's it. That's all we need to know about how we finish the machine. Okay.
Now, this is me looking at what code you have written there. You forgot or did not include state machine API.
Oh, thank you. Thank you, yes.
I don't know if it's absolutely necessary.
It is absolutely necessary. As I said earlier, if you want things outside of this plugin to see that, which we do, you need that. So thanks for noticing that. Yes, that needed to be there. We're almost at state, but I think we do branch first. Oh, no, I'm sorry. We have two things to do. So, and I'm doing this all in the same H and CPP file. There's not really very much code that this is going to require. So I'm just putting everything in here so I don't have to
wander around,
create a bunch of classes and switch between files and all that. It's just not necessary. There's not enough code. There's just going to be a few classes in one file. And now we can do that. It's been several versions since we could have U classes that are not in an H file named the same way as the class. So I kind of like to use that feature. We don't really do that at the engine level. That's not like epic internal code standard, but it's totally acceptable to do. So this is going to, okay, so our input. Now, I already butchered that one. So input to an FSA, right, is from some alphabet. So like I said earlier, the one to see if this is a valid English word would be the characters A through Z. You could have something that's letters and numbers. You could have the numbers from 0 to 255. You know, you could have a bunch of just weird symbols you made up. That's fine, but the point is that you're basically saying this state machine recognizes this character set. So these input atoms, we could have used fnames, we could have used ints. I didn't want to use ints because like using ints as your input is asking for problems, you know?
So wait a minute. So you're saying atom is a data type here? I mean,
Yes. Input atom is one atomic unit of input.
Aha, okay.
So similar to if the letter A, the letter B, like there, it's just here's the letter. It's just one thing. You can't break it apart into smaller pieces. It's just one unit of input.
Okay.
We could have called it input unit or whatever. I don't know. It's just atomic came to mind. So, so this is what we're going to pass around. We're going to pass around these miniature data assets that I didn't say are data assets. Let's try that again. All right. So again, we could have used F names, so you could pass around individual words. We could have used ints, but I didn't want to do either of those. F names has the possibility for you to mistype at some point and then not know why your state machine doesn't work because somewhere one of your inputs is wrong. Ints requires you or your game designers to have this like cheat sheet of int codes that they have to remember, and that's
lame.
That's not great. Yeah, I'm not a real fan of that. This actually doesn't need anything in it. We could just do this. We could just do that and be done. But just for debugging purposes, I'm just going to copy this over. Just for debugging purposes, I like to put that there. And I don't know that. Yeah.
Display value for this input atom mainly for debugging purposes. Yeah,
yep.
All right.
So if you want to see like, what's in this, you could look at the asset name. You could use get f name on the input atom and get its name, but that'll have like the full path and like all that pathing junk on it. Or you could have a little text description in there that you write yourself, and so it's like, oh, it's much more human readable. It's just for debugging. Again, you could seriously just erase this. The only reason I would say you should inherit it from data asset is so that when you go to put your input into it, it won't list every data asset in your project. It'll only list the ones that are this subclass. So that's the reason why we don't just use data assets themselves. A nice thing about this too is that you can easily compare these because Unreal has already done all the work for you of comparing unique object assets.
Yep.
Like that's handled. These things are going to be unique. They're going to be fine. You can move them around and rename them, and like all that is handled. Just super easy.
Sounds pretty slick.
So definitely, use your engine strengths. All right. So we're almost at state machine. We just have to do branches.
Just got to do branches.
Branches and then states. And interestingly enough, we're not actually going to have a class in the plugin for state machine because we don't need one. The machine is state connects to another state, connects to another state. That's it. Loosely, the connection of states is a machine, but formally, there's not much to go into there.
Okay.
So we actually only have 2 more classes to do. All right, now this, I like edit inline new. It's a pretty cool thing. So I don't really want branches as assets that sit around. And the reason that I don't want them that way is because they're not very reusable.
You're
not really going to want to edit them a whole lot. They only have a couple of data fields, and you're not really going to reuse them. States you could reuse because you could have, this state goes over here, but then this other state comes back to the original state. Like that could happen. But you're not going to reuse a branch really because the branch includes where it's branching to. And so you really wouldn't probably use the same branch in multiple different states to go to the same place. You could, but and you can actually create your own branch assets, but I'm going to create them inline as we edit the states, and that just seems pretty intuitive to me. You don't have to do it my way though. You could do it the other way. So, USM branch. Never type a word right. And this is also going to be a data asset. A lot of data assets today. All right. So let's talk about this. Okay, so what this needs, I'm going to copy this comment out. So what a branch needs to do is tell me whether or not you can't read that at all. Let's do this with that.
That's better.
There we go. Make it look nice and clean. All right. So what a branch needs to do is tell me if I got to the destination state or not.
Okay.
In order that I not have to ask it two questions, the first one being, did I get there? And the second one being, okay, so where? So in this case, it will just return where it got to and null on failure. It's pretty easy. So we'll do that, and this is going to be a virtual function. Now this means that in your implementation of this, you can do this differently. You could consume multiple inputs. You could consume no inputs. So you could make an NFA if you wanted to, starting by extending some of these features. So we're going to return what state we landed on, and we're going to return a modified data index to indicate how many pieces of data you consumed, and therefore what the new, so if I give you the second letter in the word, you're going to come back and say, yeah, you're going to this state, and we're on number 3 now.
Okay.
So there you go. That's that. That's the main thing that we have to do. That's really pretty much the only functionality that a branch requires, is try to branch and tell me if that worked.
And if it didn't.
Yes, and if it didn't, we'll check someone else. All right, so we're going to need some data. Of course, if you have provided a null state, you have a bridge to nowhere, or in this case, a branch to nowhere. So we can't, we can catch that, but this branch serves no purpose.
Right.
All right, so of course we need the destination state. Now, something else we're going to do, we don't really need this today, but I'll show you where you could use it, is we can reverse the input test. So basically, assuming this isn't null, we could have basically a branch that says, okay, anything but, right? So like
I'm not looking for Q.
Yeah, right. Anything that's not on this list is okay. Now, in a traditional machine, you would have a separate branch for each possible input. So if I have something where I need any odd number to go to the next step, like I'm trying to identify the pattern is like T odd number X. Okay, so T1X, yes. T3X, yes. T5X, right? Traditionally, I would have a 1 branch and a 3 branch and a 5. That's kind of annoying, though.
Right.
So instead, what I'm doing here is I'm going to let you have a list. You can just list, here's 1 branch, 1, 3, 5, 7, 9, go. So here we have a list of inputs that we accept. And similarly, if you reverse this, so this could be 0, 2, 4, 6, 8, and then check reverse input test, meaning fail.
Right.
So that's all right. All right. I don't think I actually... Well, there is a use for this. I'll show you what it is. We have other features that I'm going to write today that'll get around that.
State machine underscore API. Again.
Did I not do that? This is why there are 2 people on these things. Every time.
We're just cutting down on some debugging time later when it doesn't compile or things don't function as intended.
Or I try to create a blueprint and it just doesn't show up in the list.
Yeah, it's just like, what?
No errors, it's just not there.
Now we have to go back through everything.
And again, even though I don't intend to create blueprints with this, you can. And I also intend to export it in C++. Or you could extend it in C++. And so that's, just export it.
Yeah.
All right, so now, finally, we get to writing the actual state, which is where we sort of started. And this has this stuff all done for me, so that's nice. Okay, so we're actually going to have a constructor for this. There's one property that I have in here that's going to be a true-false that I want to default to true. I just think it's easier to read that way. And so, therefore, you have to have a constructor because otherwise it will default to false. I don't know if everyone knows about Unreal Magic, but but in all of your U classes and U structs and all that, everything is zeroed out to start with. So all your ints and bools. Strings are their own class, so they have their own constructor that makes them a blank, empty string. But all your basic types like, ints, floats, whatever, those are zeroed out at the beginning.
And a bool that is set to 0.
That is false.
Set to false.
Yep. So so we are going to need a constructor just to do that. It's just going to be 1 line. All right. So there's a little, now this is where there's some actual functionality. There's a little bit of code work to do in here. Don't worry, we'll make that usable.
It was a long one.
Yep, a lot of stuff to say there. Okay, so pretty much what you would expect it to do. We'll copy this in so you can see what it is. And some of these arguments have defaults, which is helpful. Yeah, there we go. Okay, so when we try to run the state, this is going to be a recursive function. So the state's going to try to run, and then what it's going to do is see if it can branch to anywhere else based on what your input data is. From there, it's going to run state on that state.
Right.
And keep going, and then when it tries to branch and it can't find a branch, if it has more data, that's a fail. If it runs out of data, then it checks to see if this is an accept, reject, or not accept state. Any of those are ways that it completes. Or if this remaining steps variable right here, which it drops every time it gets through, if that hits 0, then it determines that, you only asked me to run for so long. I've run for that long. We're still not done. So it'll return an out of steps result.
Gotcha.
That's the one way we get out of steps. -1 practically means unlimited steps. Practically. Because it's about 4.2 billion before that's going to wrap around to 0.
So we're good for a little while.
Yeah, we're good for billions of steps. Don't make a state machine that runs for billions of steps. You probably have a loop in there. Again, Turing Church, 80 years ago. We can't tell, but I think you have a loop because it is 4 billion steps long. Okay. And again, with the DFA, that's not even possible.
Right.
You will definitely run out of input before then, unless you literally gave me over 4 gigabytes of information for some reason.
Hey, man. I could do it.
I got a lot of stuff to say.
Just give it one of my hard drives to read.
All right. So, yeah, I mean, right. Okay. Now, we have a feature that DFAs don't normally have here. This is where we're not going strict computer science here.
Okay.
So one of the features is going to be if I see an input that I don't have any branch for, what do I do? The default answer for a DFA is, not accept. There's no branch for this data, done, fail. But we don't really want to do that. You could have a check that could like assert and like bring your whole game to a screeching halt if you wanted to, but I don't really feel like doing that either. Instead, what I'm going to do is loop. It's just skip this character and redo this state with the next character in line.
Okay.
However, since that's not necessarily what you want to do, we're going to have that on a Boolean. So you can decline to do that.
You can decline.
And that, by the way, is the Boolean that we're going to default to true. That's why we need that constructor.
Okay.
Because it's a really helpful behavior just to go, oh, you don't know what that is? Okay, ignore that. Whatever. Don't care. Keep going. Just for most games, that's going to be easier. And especially for game designers who might not be super familiar with state machines, especially the first time you show them one.
Right.
They will probably not think of every single option at every step. And you know what? Even if they did, it's kind of annoying to have to explicitly state everything at every step.
And then suddenly you insert one chunk of bad data, and your entire state machine falls apart, and you're sitting there banging your head against the keyboard, versus just simply, it's okay.
Oh yeah, could you imagine that? Like,
it's okay.
I go talk to this character, and then the game crashes, or some quest fails, and it's like, why? You have no idea in what game system this crash is coming from when it first. That's terrible. Don't do that.
Nope.
So we're trying to make this a little bit robust.
Yeah. We're gonna be friendly.
Yes. Okay. So now we've been talking about things being accept or reject or just not accept states. So this is it. We just need to take that completion type thing and put it here. And the reason that we had, let's go all the way back up here to where we wrote that. UMeta hidden. So what UMeta hidden does is when a user in a like the blueprint editor clicks the drop down box for this type, out of steps won't show up.
Right.
So I like that tag. A user should never put that type on a state, so now they can't. You'd have to do that through code, in which case,
what are you doing, man?
Your fault. All right, almost through the data we need here. So this is also another convenience. A traditional DFA, if you got to a state where it's like, okay, DOG, I don't care what comes next, that's a word. I love dogs, and anything starts with dog is a word as far as I'm concerned. That's a really bizarre thing to do to your language.
Dogs, dogma.
Dog.
Yeah, right.
Just anything. But yeah, if you just say like, as long as you do these things first, anything you do after that doesn't matter. It's automatic fail or automatic succeed. The traditional way to do this would be have every possible character in the language self-loop to that one state, and then just keep running the machine until you've run out of input. That's silly. We're already here. We know it's going to end. So here's a feature where you can just say this state ends as soon as you get to it.
Yes.
You just check.
I have the desired input. I don't need any more.
Yeah, no further testing required. And remember, theoretical computer science is about getting the right answer, but practical programming is about getting the right answer in as
as
little
few steps
time
as possible.
And game development is about getting the answer that looks right or fun to the user. So there's an element of smoke and mirrors. There's an element of art to this, and this is part of that. Like, this is just a feature. It doesn't need to be there in the mathematically correct model, but it's kind of helpful.
But yeah, you need to cut down on some of those cycles.
Yeah, there's just no reason to waste them. Okay, and loop by default, we've been over what that is, and the comment says it pretty clearly. And then finally, of course, the thing that we absolutely need, the main attraction, the branches. We, of course, need branches to other states. Now, we're going to take these in priority order. So again, in a traditional DFA, you would have one branch for each input, and that's it. But since, so I mean, we could do that here. That would be fine, because there's probably not going to be an input that goes one way with, input A, and then a branch that goes another way also with input A.
Right.
Right. Like, we're probably not going to do that. But in case someone wanted to extend this to be an NFA somewhere down the line, we're going to just tell you that the way this one works is, as soon as we hit a branch that passes, we take that branch and we don't look back. And that's also another, let's not waste processor time.
Yep.
Like, I don't want there to be multiple branches that pass on a single input, but if there are, I'm taking the first one I hit.
Right.
It's fine. And for other games, by the way, there could be a reason to do this. Like, I press the attack button, and then maybe the state machine reads attack button, but it also wants to look at your character and say, are you in the air or on the ground? Because I'm going to go to a different place based on that.
Right.
So that kind of thing could be a factor. Okay. So that's it for that class.
Yep.
Let's see if we typed everything right.
First big build after. Oh.
Not a surprise. I don't remember typing UN64 though. That's in object-based.h. Oh, that usually indicates a different mistake.
What'd you do?
Did I not? I think I may not have. All right, so I may not have put in. Oh, Visual Studio really didn't like that.
You just opened a build CS file.
I just opened a file. Okay.
Okay.
Okay, that's fine. Let's open that back up. Was this the right one?
I think it's the down one.
Yeah, no, it was this one. Yes, thank you. That's correct. Okay, we'll just reopen that.
What was that? Be careful when yep.
Wow, that's amazing.
Is there something?
I don't know. Do we not have maybe this this install of Visual Studio doesn't have the C# parser on it?
Can we?
That's weird. I mean, we can still open it in
Let's
Notepad.
open it in Notepad. That's really kind of weird, but it may not. Because we open these things.
That is strange. All right, let's put. Come on, you. Wow. Okay, Visual Studio. All right, buddy.
IntelliSense is exploding.
Let's calm down here. Okay. Oh, we don't have everything on this computer. I love everything. Such a good little utility.
Are we talking about Notepad++? Because we can totally get Notepad++ on there.
No, I mean the utility called everything. It's that super fast searching tool. So that I could type splat.build.cs and then
I can't tell if you're being facetious. I've never heard of this tool.
Oh, it's great. Yeah. It's a free thing and just like a file searching thing, but you just type in.
Seriously?
Yeah.
Huh.
I use it all the time because you have so many different projects and you're like, all right, which one of these like where is my documentation for TSET?
Okay.
And you just type it in, it comes up like instantly. It's really good for because I have like 15 different workspaces.
Mm-hmm.
And they'll
you
have
need to know
these
specifically.
long
Yeah.
directory chains. So we were in Stream Stuff.
Project development. Plugin development.
There we
fully
go.
Spelled.
And see, I would just type splat.build.cs right now and be done.
Plugin, state machine.
State machine, source.
State machine.
Come on, buddy. All right, here we go.
There it is. Notepad.
So what I'm thinking, not right now. Thank you.
Cancel.
Okay.
Drag that on over.
Drag. We still have all this zombie stuff
Yep.
up here. Whatever. You guys have seen that before, so I need to hide that. And then also I want to see the one that's on the C drive. Just for comparison, I think, so to tell you what I'm doing, I think I forgot to include a module that we might need.
Up one. Plugin development. Source.
Thank you.
Or
there we go.
Pardon. No, back up. Plugins. Plugin development.
How
plugins.
did I miss that? There it is.
So state machine. Source.
State machine. I'm pretty sure
And
I
there's
even know
your-
which one it is. I'm just doing this to double check. No, they're the same. That's very odd.
Are they?
They look the same to me. That looks pretty much the same.
I'm gonna agree. They look the same.
All right.
So it wasn't a module.
Well, this has never happened before, but let's just check it anyway. All right, so let's just see if it's that file that we mentioned that we would probably not have to touch manually. Let's see if it's a good thing that I know that. Backing up. State machine, and if not, we have the pre-made version anyway, so we can keep going. Wait, am I not going up far enough? There it is. Intermediate build. Why is this slow? Oh, because this is parsing.
Yeah.
Well, yeah, that thing we avoided.
Actually, I think they're
they're
both
come
parsing.
on. Okay. I didn't mean to do that. I didn't mean to click that file. Just the lag. I'm blaming it on lag.
Yeah, we have two Visual Studios here that are actually parsing their. I believe it looks like the entirety of UE4. Nope, that's supposedly in the right
No,
order.
That's fine. We didn't need to touch that. It was totally fine. All right, I'm going to try this once more.
Yeah, let's see.
Oh, wait, you know what? This is totally not going to compile anyway because I just defined a bunch of functions and then didn't write them. So
maybe that's the issue?
I mean, that shouldn't tell me that it doesn't know what a uint64 is, but at the same time, this shouldn't work. Not state machine.cpp. smstate.cpp is the one that I want. Okay.
Different errors this time. But
Yeah, okay, this is fine. That's fine. That kind of error is okay. All right.
that kind of error is okay.
Yes. All right, so I have pressed the button to go over there. I have pressed the, well, you can see my little swirly thing here.
Where are you trying to go?
I'm just trying to go to the CPP file
Ah.
that's already open.
Well, yeah, but it's parsing all that data.
It
right?
sure is. It is definitely parsing a lot of data right now. All right. I don't know.
Problem with Visual Studio and
You know what? I think if I go over here, I can tell it to disable VAX temporarily and maybe
Nope.
Maybe it will continue to parse.
Don't care. It's like I got in my commands.
Oh, there we go.
I got my marching orders.
All right. So now we have to write those functions. So right off the top of my head, I know that we need a constructor for USM state. And the only thing we need to do here was set that looping. You're not going to autocomplete for me, but you will take the time to parse. Okay. Oh, I don't know if... And I can't hit all... Okay, good. Okay, good. I thought maybe I got tempted and tricked into doing that when I shouldn't have. So you notice I do this with a lot. Like I don't say bool. I do this. So this is saying it's a uint32, but only use 1 bit, which is kind of like a bool.
Why would you do this?
So right, because this seems crazy and
it seems kind of crazy.
Just looks more complicated than just typing bool.
Because there's a bool.
We have a thing for this.
Yeah.
The thing is that a bool will take up its own spot, which could be like 4 bytes.
Okay.
If I have a bunch of these in a row, they will be compacted into bits, and I can get 32 of those in 4 bytes. It's not a big deal, but it kind of inflates. It makes your booleans basically 32 times bigger than they need to be.
I don't. Okay.
Yeah, it'll just go like, oh, you want a bool? Here, have a uint32 that you're just going to use 1 bit of.
Okay.
Right, and instead I can just say, just pack these things in, and I can get 32 of them in there. So, like in this case, I only have 1. It doesn't matter. Down here, I have 2 in a row, so I've saved myself 4 bytes.
Mm-hmm.
It's just a good habit. I mean, like, there's no... I'll make bools for local variables, but since they take true and false, not 1 and 0, like they look exactly like bools anyway. There's
there's no point to.
Yeah. I just always do that now.
Interesting.
Yeah. And Unreal recognizes them as bools too, so it's all clean all the way through. Yep. All right. So we needed that. We also need a couple other things. So we need the branch to try to branch, right? We need that function. And I have the header here, so we'll just copy that right over. Let's make this a little easy. There we go. That fits. All right. Now, this ref object, by the way, you may have noticed me putting this in here. This is totally unnecessary for the state machine. But if someone has a reason to extend this and they want some context beyond just the input atom, that's why I'm giving you this.
Okay, so the ref object could be a character or a quest NPC or a fight move or a fighter.
Yeah.
Whatever, right?
It would usually probably be your player controller or something like that, where you can just get to whatever information you need.
Gotcha.
Yeah, I don't know. Like if I press the auto attack button, maybe you need to ask my character if that character is targeting someone for auto attack to determine whether or not you take this branch.
Okay.
It could be anything like that. So I just put it there. I never use it, but you can.
Okay.
And again, that's just thinking about extensibility. All right, so for starters, just this way we can't not set that and that's a mess. And then it would just be whatever value it had before, which could have been garbage memory if you expected this to work. All right. So, first thing we always have to check. All right, if we don't have anything in the acceptable inputs list. So we have data index there. We need to check if we went past the edge, because that would be bad. So if there are no characters that you're willing to accept, or if you've gone past the end.
Yeah, you don't have a not there.
Yeah. Oops. Yeah, there shouldn't be one. And I guess I should put that on another line. Well, we'll get to that. There we go. Acceptable inputs.
Contains.
Yes, dot contains. I'll do this as a line. I think this is more readable. What was our input atom? Data source. It's the data source.
Data source, square bracket data index.
Okay, so here's our condition. And this is going to say read one piece of data. And there we go. So this is some pretty compact logic here. But basically this is saying, all right, if you didn't give me any, if there were no acceptable inputs for this branch, or if, should that say that? It should say this because it works, but, yeah, I'm wondering about this not. No, I've tested this. Okay, so, yeah, basically this is seeing if the branch should pass. Like, this makes sure that we're not out of bounds with the array check, and then this checks that the acceptable inputs contain the thing that we want. I really feel like this should say... No, it should say that. That's right. That is right.
Well, because there's an or there, right?
Yeah.
If it's not acceptable, or if the index is valid.
Right. And that doesn't sound right to me, even when you say it.
No, really,
It really sounds completely wrong. However, this works.
However, the proof is in the pudding, right?
Right. And if it comes up with weird results, we'll come right back here first.
Yeah.
But it worked when I tested it out about an hour ago. So. And then this is. I'm really, really so suspicious that I'm going to look.
This is where it starts. He's double checking himself.
You know. That's not what I thought I'd see here.
Yeah, blank file. That's interesting.
That's freaking me out a little bit. All right, moving on. Don't know why that's blank. Okay, so anyway. Destination state or null pointer. So I like the ternary operator. I like the inline comparison, right? If true, this one. If not true, that one. If you're not familiar with that, it just saves me from having to spend several lines on an if. We'll get back to that very suspicious piece of code later if anything acts up. All right, we did the constructor. Now let's talk about the actual seeing if or the actual running our state and seeing what happens. Oh, cool, that fits on 2 lines. All right. So here's our run state. Here's like our main workhorse function, and this is where we're going to do, pretty much everything in our state machine.
This is a chunk of code, isn't it?
This is going to be the main work of the state machine right here. So let's look at that. And let me get that bool up here.
Yep.
So, all right, we know that we need to know whether or not we're gonna end our run, or continue on. Now, if we've said that we're going to terminate our run here, then we're going to terminate our run here. That's decided. Similarly, if we have no more data to go through, now this is the sort of thing if you want to make an NFA, you're going to need to override this function.
Okay.
Because you could have null branches that don't consume any data, and even though you're out of data, there are still branches left.
Places you could go.
I don't know why you would, but you could happen to run out of data at a place where there's a null branch, and then you have to check it. I mean,
yeah,
you could probably get away with not doing that if you design your machine right, but if you don't design your machine with that in mind, you might need that check. All right, so we're checking this isn't 0, right? That's our recurse guard, so we don't just infinitely loop. You put a number like, I don't know, 10,000 in here, something like that, something gigantic. By default, it's -1, and I copied over the defaults here just so you can see them. We do this in the engine a lot. It's just when you're reading the code, you don't have to go check the H file. That is so bizarre. I can't not think about it.
You're just grinding on it.
Oh, that
Well,
code that I
look,
wrote
there's only
earlier
one. There's only one way to find out, and that is get the rest of the code in there and run it.
But I ran that.
And it worked.
I ran that and I clean rebuilt it too, and it worked. There's some Twilight Zone stuff going on here.
Maybe we opened the wrong project.
Yeah, I'm hoping that I just opened up the wrong project, because that makes sense, and it also makes sense for why it was parsing. But it was on the most recent list, which is why it's weird. Let's just check that one more time.
Yeah, because there's 3 of them there.
There are 3 of them there. Man, which one was I running?
Well, it's one of the top 2, but oh wait, there's 4 of them there.
There are 4 of them, and these 2 are named differently.
What am I gonna do with it? Seriously.
Oh man, this is man. Sometimes at home I get the complaint that I don't keep things in order.
Really? I can't imagine that.
She doesn't know what she's talking about. All right, so let's do this. All right, so so if we finish here, then this would be our destination data index. So basically, when we get to that next state, we need to say, hey, next state, here's what state you are. Here's where you start reading this long string of input. Because we're not, like, that input string should be a const tier. Yeah, it is. It's a const tier, right? So we're not, like, chopping data off the back of it. Especially because you might feed this data into one state machine and then feed it into another state machine, and I don't want you to have just mangled my data. So, or actually even go into one branch and then go into another branch in the same state if your branches are modifying it, you know.
Yeah, then everything goes
like for
downhill real quick.
Yeah, like for an NFA, right? You go in, you come back, you need another copy of that data.
Right.
So we just give you the index. It's also just better for speed and performance in general because we don't have to shuffle stuff around in an array.
Right.
We just change where we're looking. It's way better. All right. So now we're going to go through every branch we have. Now, there should not be any null branches in the list, but I still wrote this as an if instead of a check, right? So I could just do this. Check, and that will basically assert / crash your game if that's not the case. That'd be fine. That'd be fine, and sometimes that's a good thing to do because then anytime you make that mistake, you know about it immediately.
Right.
The problem is if you haven't saved your file or something like that, and you crash the game, you can just undo some work.
Yeah.
So I'm going with the softer approach here. I could also be using an ensure. That would be pretty good because an ensure will print out a message to the log like one time. And so you'll have this log warning, and you'll know that you messed something up.
Right.
One time per run, though. So you have to shut down your engine and start it back up again to reset the ensure thing in case you have 2 mistakes. Because it won't tell you the second time. It will only tell you. I think there's an ensure that does it every time, but usually to avoid log spam, you use the ensure that only tells you once per session.
Right.
Better than crashing. And this is just silent. So this will just let you have your mistakes and just not tell you and just waste time looking at empty branches. All
hey man,
approaches.
This is what you wanted.
All different approaches. All right, let's just space this out so we can read it a little better. All right, so we know where we're going. We're going to try to branch. Now remember that the branch will come back with the state that we successfully went to or null. So that way we've done this in one line. And the result of this, if it succeeds, is pretty simple. So we check to see if that's not a null state, especially because we're about to do this to it. So if it's not a null state, then run it.
Run it.
The ref object just gets passed through. The data source just gets passed through. These things aren't modified. The destination data index has already been set, and we're subtracting 1 from the remaining steps. Did we not increment the destination data index? There is stuff in here. Oh no, we did. Remember that try branch changes destination data index. So the branch has decided how many units of data it's going to consume. In this case, it's always 1. But you could override a branch. You could have your own special type of branch that you know, maybe like it's like you're looking for a triple press, like Street Fighter. You got to press all 3 punches or something, and it just goes, yeah. Do I have punch, punch, punch? All 3?
Right.
If so, okay. And in that case, it would consume 3 inputs. So you can do this. We don't here yet. All right, now, supposing we get all the way out of that loop, right? Because this is a return. So if we don't hit this return, then that means we got through this entire for loop right here without finding any branches that were acceptable. Yep. Okay, so let's deal with that. Oh wow, that comment just fits. All right, so we didn't find a branch. Again, like I was saying earlier, the default thing for a DFA to do is to go, okay, fail. But
we're going to go ahead and loop through
kind of a pain. Here's an option where we're going to loop. This, instead of just being a recursive call back to yourself with those exact parameters, just in case you wanted to do anything special on looping, I've provided a way for you to do that. You'll also notice that we normally subtract 1 from remaining steps, but when we go to loop, we don't.
Yep.
We'll address that in a moment.
Because it'll be done in the loop state.
Yep. Now we've addressed that. All right. And either way, we know we have to end because we're not looping. We didn't find a thing to go to. There's nothing to do now.
Yep. So time to terminate everything.
Yeah. So we gotta terminate everybody. That's the best way to.
I said everything.
Oh, you did? You should have said everybody.
Terminate everybody.
I'm gonna terminate everybody. We're done. All right. Okay. So here's where we use the state machine result. I just didn't feel like typing it out that many times. State machine result structure. Now, it would be a little bit cool if we just called it a little. It's in the nerdiest possible sense of that word. But
okay.
if we had a constructor that would just take these 3 arguments and do that, but so we could have a constructor that does that. I just didn't want to write one in the H file, so instead I do this in the CPP file.
All right,
it's fine.
whatever.
It would be.
It's acceptable, yeah.
It would be better for functionality to do it as a constructor because that way people won't forget to set data index in an overridden class. So that would be a slightly cleaner code way to do this. But
yeah, all right.
Yeah, it's all right. All right, so we need to know the final state, which is the state we're in. We need to know the data index, which we already know. And then here's the completion type. And the only way that we get out here without setting must end now is if we don't go into this loop, which means that must end now was false, and we ran out of steps. Right? Because every other way out of this loop runs through this line. There's no other way.
Yep.
So therefore, if we did have must end now, we can use the completion type. The completion type from this state.
Right.
If not, then we know that that's not actually what happened. What happened was we ran out of steps and we skipped the whole checking branches thing because we were told hey, just don't go any more than 10 steps. Come back and tell me if it takes more than 10. And then we return that. Now, and that is again why we need this and this. Because that way, if the person wants to...
Sorry, just this, and you highlight this.
Yes,
and
I
this.
know. I thought that was...
Wait a minute.
That worked. So yeah, that's why we need final state and data index, so that if the person says, okay, well, next frame we'll do another 100 iterations, and the next frame we'll do another 100 iterations, because I have a lot of these things I'm parsing, and if I check every one of them in the same frame, maybe I have hundreds of state machines. It's like, look, any given state machine can only do 10 steps per frame.
Right.
And if it takes you 10 frames, that's fine. I'd rather have it spread out over part of a second than have the user get just this big jolting hitch in their game.
Yep.
So that's what that's for. So just a nice little feature. And the loop state is actually really simple. Again, it's really just there so that you can override it in your own classes. But this is all it does. It's one line.
Right.
You run the state.
Your data index +1, your remaining steps -1.
Move to the next character. Admit that we took a step. Move on.
Admit that we took a step.
Right. Admit that we took a step, because if we don't admit that we took a step, and you really wanted to limit me to only 10 steps, then any state that has a bunch of garbage data in it, 50 things that I'm ignoring, that won't count as a step.
Right.
So now I'm taking 60 steps instead of 10.
All right. Let's see where we.
Let's
see if that uint 64 thing pops up again.
Whoops. Oh, I have a bad feeling that it did. Missing brute before U class. Oh, okay. Did I? Yeah. Well, because I'm missing a semicolon before U class. So exactly the thing that it said was the problem.
Because
that's why I said this error is okay. Because when I first saw that,
that's your enum.
This is my. No, this is a previous class. So.
Gotcha.
Yeah, all those declarations have to have that at the end. Yeah, that's why when I saw that, I was like, I know that one. That's a real error. And then we just moved on, and I sort of forgot what it was. But yeah, I don't know. You see one of those things, and you're like, I'll know what to do with that. That will not be a problem.
It's okay. We'll come back. We'll come back.
And come back later to an unpleasant surprise.
All right.
This, on the other hand, is not cool. Wait a minute. Maybe this is cool. I just want to make sure that this is... Oh, did you want me to say that? This type up here... Yeah, I did say UN8. Okay. If you forget UN8, it will not like that. It doesn't want to make a U property out of something that's not a byte, which is why you need T enum as byte, or you do that to make your enum a byte anyway. There's actually a specific UHT error message that says, can't do this unless you declare it as whatever, or... Oh, yeah. It doesn't know what a USM state is. How would it? USM state is down here. Because I didn't tell it that there's going to be a class later named USM state. I'm not sure if I use branch anywhere either. I might use branch early. Probably not, but you know what?
Was that in your notes over there?
I
don't think.
I don't know if that was in my notes, but it's definitely something that I remember coding. Yeah, I didn't put my forward declarations in my notes.
Oops.
Good thing I actually know how to program and can spot these things.
Yeah, because I'm like, dude, I have no idea what you've done.
Yeah, that
you broke everything.
That's okay. I kind of like how this works out, because this is what programming actually feels like, except with way more...
And it succeeded.
Way more pressure. Yeah, and it's fine. It's fine. But, I mean, I don't know. It's a more realistic view of it, minus that this never...
I know.
Never happens.
Yes.
Oh, we're not actually running the engine. So we don't need to recompile, but we do need to run the editor. So, yes. Yeah, hot reload generally works, but when I'm adding classes to a plugin or whatever, I think it actually does work in that case. It's like still fine, but I guess I'm just amazed that hot reload works, because it's like, because I know I know enough of the internals to be like, oh, that's a terrifying feature. But we have people who are super smart, and so they wrote it so it works.
Yeah. But sometimes it's just amazing.
It's just, I don't know. I mean, it's like don't get into an airplane and then think about what you're sitting in. Like, don't. Smart people made that work, but don't think about it.
Or the lowest bidder, whichever.
Yeah, or the lowest bidder, who hopefully bid high enough to have some smart people on staff.
All right, so our plugin compiled.
So we're
back in the editor.
Yes.
And
we're in fun data time.
We can check to see if it loaded.
And
it
hey,
totally
look,
loaded.
Still is 100%. Wait, oh yes, you can see it. Yes, it's 100% loaded.
Now we can actually make things.
All right, so today, what we're going to make with state machines, there are a couple things I wanted to do, like fighting game input, and I've sort of hinted at that a little bit, but we're not going to do that today. We'll do that later.
Okay.
Instead, today, just I thought the fighting game input's cool, but what's like a really obvious game use of state machines?
Right.
And so the answer is animations, but we already have blueprint state machines, so...
Yeah, we kind of don't need
So we're not going to do that. But another good one, another behind-the-scenes good one that's best done with programming, because this is kind of C++ centric, in that we just spent an hour and a half writing code.
Fair.
This is kind of C++ centric. You know, we're using data assets. We're not using like blueprint graphs or whatever. So what's a little more programming? Because animation, you might have an animator actually looking through blueprint graphs, and they don't have to be programmers.
Right.
But behind the scenes stuff like quests in MMOs or RPGs or whatever, that's like behind the scenes code stuff. But state machines are nearly perfect for that. I mean, it's exactly what you'd want, right? You did this and then this and then this, and you didn't do that, and then this happened. Done.
Okay.
You complete the quest or you fail the quest or whatever.
So how do we make that now with the tools that you have created?
All right. So the first thing we're going to do is we're going to create a folder just to set up our data. To be nice and clean. So quests, and then within quests, we're going to set up a couple of things for state machines. So here we're going to have any quest. Did I spell it right? Yes, good. Any quest. So there are going to be a couple of generic states that any quest has
access to.
Yeah, that they'll all just use, and I'm just going to put them here so that we don't duplicate them and so that they're sort of kept off in their own little box.
Okay.
Two of them that come to mind. So the first one is going to be, and there is a little bit more code to write, but we're done the plugin part of the code. Now we're going to write a little bit of game code to do this.
Okay.
The first one is going to be a data asset telling us that we have failed a quest. Any quest failed. Pretty simple. Terminate immediately. Rejected.
Now we can start to see some of our features that we have built. There they are. This is where we're going to access them.
Yep, that's a pretty simple state, and we're going to want any quest succeeded. I think I typed that right. In any case, the beauty of this not being not using strings is that there will just be a misspelled succeeded in the list until I fix it, and it'll be fine.
Sorry about the mic there. I just popped it off my ear.
So again, terminate immediately upon reaching this state and accept. I don't care what input there is. Loop by default, and I'll just leave it on. It doesn't matter. We're always going to accept if we hit this state. We're always going to fail if we hit that one. Okay. Now let's come back. So here's the quest. The quest is...
Kill 50 wolves.
No, because that is terrible.
Okay.
The quest is going to be cooler. It's going to be to kill one thing, but it's going to be a dragon.
Okay.
So you need to go and talk to the knight, and then the knight will tell you he wants you to go kill the dragon. Then you kill the dragon. Then you come back and talk to the knight again.
Okay.
Now, there's also a wizard who you can talk to. The wizard has nothing whatsoever to do with this quest.
However,
we do need to be aware of it because talking to the wizard is another possible input atom on our quest.
Okay.
So let's go through the things that we can do in our quest. There are also other ways to fail the quest, such as killing the dragon before you talk to the knight. Means that the knight never offered you a reward to kill the dragon, and so you're not going to get one.
So he high-fives you?
Yeah.
That's about it?
Hey, great job, but I didn't offer you anything for this.
Yeah, I'm gonna keep my gold.
Similarly, making the knight hostile to you one way or another, angering the knight, will mean that I was thinking of possibly just slapping him right in the face when he goes to shake hands with you. Knights, I've been watching Game of Thrones a bit, and it seems like that would be a terrible idea.
Get you killed.
Yes. So, yes, data asset, and this data asset is going to be an input atom. So we're going to talk about what types of inputs we can have. Okay, so one input we have is that we kill the dragon. That's a thing that can happen. So what we're going to do is we're going to make a quest log of all the stuff you've done, and then that's going to be fed into a state machine that is the quest and determines the outcome of the quest.
Okay.
So you can kill the dragon.
Does that have any data on it?
And remember, these don't really need any data,
it's just
but we have the display name. Kill the dragon. Okay, great. So if we ever want to print out that we did this, now we have a convenient piece of text for it. We can also have talk to knight. Okay. What else can we have? Save those. We have talk to wizard.
What the? Oh, okay.
Okay, I guess the rename just took a second. Okay, talk to the. Wow, this is really hard to. Like, I'm just hoping that I'm typing things mostly correctly.
We're checking you. Looks all right.
And what else? Okay.
Kill dragon early, or
that'll just be kill dragon. So your game.
But you won't have talk to knight, so the state machine will process out for you.
The state machine will determine that it's early.
Okay.
Because the game doesn't know that it's early. It's only early in context of this quest.
Okay.
Okay, so Night become. All right, I was gonna say night becomes hostile, but slap night. Okay, that's one. I also had a state in there for if the knight dies by a means unrelated to you. I'm gonna do that because it will always be the same as if you make the knight hostile.
Mm-hmm.
But and actually, I'm gonna say night becomes hostile for this one because I did some things alphabetically that I'm sure I will mess up.
Okay,
It doesn't matter.
Fair. That's fair.
It doesn't matter. It's not in the code, but it's just in my head.
It's in your head. All right.
I like slap better though. I wish I had been talking to you when I was writing this. All right. Night becomes hostile, and I've just been copying the data assets. By the way, I've been hitting Control W to duplicate them because they're such simple assets that
why not? Right?
It's just like it's fewer clicks. Knight dies. Okay, so those are the 5 things that can happen. There we go. At least we got a little bit of that flavor in there. All right, so that.
This dies.
Doesn't matter how the knight dies. Maybe
Killed by the wizard.
Yeah, maybe you just leave long enough and other events happen that lead to the knight dying. Yes, that too. Night has aged out of existence. All right. So let's make that knight's quest. And then there's still going to be one more thing to code, which is going to be our game's idea of what a quest is.
Right.
But that'll actually be pretty short, I believe. I think I wanted actually a folder, didn't I? Yes. So this is going to be the state machine, the state machine stuff for the knight's quest. All right, there are 3 basic things in the knight's quest. There's you accepting the mission, you accomplishing the mission, which is killing the dragon, and then you actually talking to the knight again.
Right, turning it in.
Yes. So, where are we here? There we go. Miscellaneous, data asset, state. Okay. So, for convenience sake, we're going to have knight quest start.
Okay.
That way, when we go later to identify the quest and where the first state is, it'll be pretty obvious.
Gotcha.
So night quest start, and we're also going to need. I don't know why I didn't just copy that. Night quest mission accepted, and night quest mission accomplished.
I think you had.
Yeah, I did. I did. Messed that one up. All right, so
I'm running out of cable here.
when the knight's quest starts, well, what state is this? Well, it's not accepted because you haven't won yet.
Right.
It's not rejected because you haven't lost yet. So it's just a regular not accept state, and we're not going to terminate here.
Okay.
All right. So there are going to be 2 branches here. Pretty much at any time in this system, there are probably just going to be 2 branches. So branch 1. Oh, and by the way, this is where if you have a type based on SM branch, right, if you derive your own type, it'll appear in this list.
Gotcha.
So we're just going to use my regular old branch type that we made that the plugin already has. So let's talk about failing the mission first. So we're going to use the AnyQuest failed state. All right, so how do we fail? Well, what inputs would lead us to fail? One is dragon's already dead. No good. He's not going to pay you for that. 2 more ways you can fail this. Knight becomes hostile. Knight dies. Any of those before you've talked to the knight pretty much means you're not finishing this quest. So those all go straight to AQ failed and do not pass go, and you don't get any monies. All right.
No $200.
The only way to succeed here is to, where's talk to knight? Oh, whoops. Sorry. To accept the mission is to talk to the knight.
Okay.
Okay, pretty simple. Let's go on to look at accepting the mission. Like that little magnifying glass button just takes you to the asset that we named there. Again, not accepted. Yeah, go ahead and loop. And this isn't a termination state. All right, so branches, which I called instance branches. You could have these branches as data assets, but like I said earlier, that just wasn't how I felt like doing this. I felt like making them instance. And originally I had both. I had instance branches and non-instance branches. And you could do that, as long as you don't, you just run through one array and then run through the other array. You don't care, just whatever the first one you hit that wins, you go.
Gotcha.
But that way you could do both. I just didn't because this is long enough. Like I didn't want to make this, because we're already kind of going for a while. All right, so where do we go? Well, this is our fail. I'm just doing the failure stuff first. All right, so at this point, killing the dragon is okay because we've already talked to the knight.
Yep.
Slapping the knight, still not considered
and the knight died.
mannerly.
Yep.
Also, slapping the knight to death, also not mannerly. The only thing we can do at this point that succeeds is to, right. Sorry, that goes to mission accomplished. The only thing that goes there is killing the dragon. Now you'll notice that we didn't mention talking the knight this time. With auto loop being on, if you go back and talk to the knight again, it'll just loop. The other thing we could do, and this is how I know that branch supposedly works right, even though it looks really weird to me, is we could have a branch that goes back to our current state. We reverse the input test, and we have nothing in here.
Okay, all right.
So this will always fail. We will reverse that failure into success, and we will come back to the state we're already in, and we'll just loop over and over again. And this will catch all inputs that that weren't listed in one of the, just make this your last one, and it'll catch anything that any of the previous branches didn't catch. The thing is, I found myself writing this for every single step. So how about if instead I just have a bool? Just have a little checkbox up here.
Right.
That's on by default that just does that. Because, I don't want to go off the rails here, but like if you come back and talk to the knight every 5 seconds and then go kill the dragon eventually, like that doesn't do anything to your quest. So just ignore those. All right. So that's pretty good. Now let's go see mission accomplished. Mission accomplished is pretty straightforward too. This is still not quite victory yet. Remember, you've only killed the dragon. You haven't actually gone back to collect your quest reward. There is still time to slap that knight in the face. You have one chance.
Don't talk to him. Just slap him.
Just walk right up, and when he's like, "Oh, hail, sir!" Bam! Right across the face. Swords are coming out. It's going to be great. All right. So, again, failed. And again, the same two conditions. Either the knight has become hostile, or maybe you just didn't return for so long that he died some other way.
You got sidetracked, saving the world, and
yep, you just never collected your dragon.
You're sitting there, you're 80 years old, king of the land, and oh man, I could have had that extra 200 gold. I wonder if he's still alive.
And the answer is no.
No.
All right, and here we'll use our any quest succeeded branch, and the only thing that you have to do for that is talk to the knight again. So there you go. That's a quest. Now we probably should write a system that actually runs quests. So let's do that. All right, so this time we're going to add a C++ class. And it's just going to be another data asset. There it is. And this one is going to be in... Oh, wait. Yeah, this one's going to be in our main project, right? Not in the module, or not in the plugin. It's going to be in the main project. Now, again, this is the point where we would move the plugin out, move it to a new project that's called like RPG time or whatever, and then Adventure time. That one's taken.
Yeah. No, I see what you did there.
Yeah. So yeah, put this in the main module, and this is going to be called, I don't know, quest. I think I called it. Let me. Oh, did I not even open the other one up? All right. Well, anyway.
Quest works.
Yeah, I think quest is the name. I just want to be consistent, so that if I cut and paste something, it doesn't totally mess up.
It'll explode.
Yeah. It just makes it easier. So yes, quest is the right name. Which really I should know because, my brain came up with it one time, and I'm going to do the same thing next time. Pretty deterministic in that sense.
You say that, but I also find myself like not being able to stick to a naming convention consistently for assets when I'm moving between projects. So one project will just we'll have one set, the next one will have the next set, and just for whatever reason, that moment, that mode that I'm in, just whatever.
Yeah, I mean, all right. I think I'm a little more the other way, but
you're far more disciplined.
I see how that, more predictable. All right. So quests, we'll do the same thing where we kind of start from the top. All right, so quests are going to have pretty much the same results as a state machine because quests are state machines, so they're going to be similar. There's a little difference though. A quest cannot be started yet, or we can start it and then we can of course succeed or fail. The interesting thing about the started state is that's going to be the only state where we actually run the state machine and actually check, because in any other state we just don't care.
Right.
All right, so let's get into our quest. All right, the name of the quest, that's pretty much just decoration. The quest is going to need a state machine. Just copy those in, save some time here.
Also, plugin development API is removed on your notes.
Oh.
I don't know if it's necessary or
It's not really necessary, but thank you for noticing.
Yeah,
yeah, that doesn't need that can be there or not. It just happens to be there. Okay. So let's see. Quest name, again, this is just whatever. You might display this in a list of active quests or something like that. F-text is what you normally use for text that's going to be localizable. So text that's going to be displayed to a user, you use f-text instead of f-name or f-string. Okay. So the state machine, you notice, doesn't have, like I said earlier, it doesn't have a state machine structure. It just has what's the first state, and that's it. And we're going to assume that the data index starting is also 0. Just pretty sensible stuff. Now, we're going to have, remember how I said at the very beginning of this that there's like a set alphabet for any DFA or NFA or whatever?
Yep.
So even for Turing machines, like all of those have a list of characters that they accept or whatever. So normally our input's going to be a whitelist. It's just going to be a list of here are the set of characters we have. You could have a blacklist if you wanted it to be like, oh, it's every character except these. But as you make more quests and more input atoms show up, it's really not convenient to have to go through all your quests and explicitly exclude all the other ones.
Right.
So the idea here is that what we're going to do, we're going to have a master list of everything you've done in the game, and then each of your quests that's currently running will get new input added to it if that input is on the quests list.
Right.
So the quests themselves each quest won't have to go through your entire history. They'll only have to go through things that happened while they were in started state and that they care about.
Right.
So like talk to wizard isn't going to be on this list, and so it'll never show up in the data. It will never waste our processing time seeing how many times you talk to the wizard when that's just not related to the quest. Okay, so that's pretty much it. That's a pretty simple data asset. Now, we are going to need to know what quests are currently running. So we'll start that class here. Actually, it's a struct. All right, so this should be put on your player controller. We're going to put it on the pawn today just to speed things along. But, all right, so we need to know what quests we're running. So that's this. I've made it const because quest is a data asset. You should not change those. You just read data from them and do stuff based on it, but you generally don't change what's in a data asset.
Right.
So of course we need to know what quests we're running. And this is the quest progress status, which we just went over a minute ago. It's started, not started, succeeded, failed. And then finally, for this, well, not finally, but
yeah, there's a lot more down there.
Yes, but importantly, we need to know what's happened so far. So we're going to take an array of all the stuff that you've done in the order you've done it that is relevant to the quest and that happened while the quest was running. Pretty good.
It really doesn't like keeping your tabs, does it?
No, yeah, it doesn't, because this doesn't end with a semicolon, so it thinks it's like an if or a while or something. Okay, now, since this is a struct, we write code directly in it. I'm going to drop this code in, mainly in the interest of time, and we'll talk about what it does, so we won't just skip over it.
Yep. Double close, double semicolon at the bottom.
Oh, thank you. Didn't need that. Well, actually, probably. That was odd. All right. So, whenever you do something in the game and it creates another quest log entry, we go through each of our quests. We're going to pass it that UObject just in case we want it.
Yep.
And we're going to tell it what the quest activity was. The very first thing we do is we make sure we have a valid quest, that the quest is in fact running, and that whether or not your quest activity that you just did is on the input list does not equal whether or not it is a blacklist. So if it's a blacklist, your thing has to not be on the list. If it's not a blacklist, then your thing has to be on the list.
Right.
And from there, it's pretty straightforward. We keep track of that activity so that next time we come through and we're adding one more, we'll have the running list. So the quest tracker keeps track of its own thing. It doesn't rely on the main quest log. And that actually, by the way, means you don't even need a main quest log. Like if the main quest logs are getting to be like, millions of things long because someone played your MMO for years, you don't actually need to keep that now. Just the quests that they're actually running have these little mini logs, and they don't care if you're keeping a master list somewhere else or not.
Right.
It just doesn't matter. All right, so the quest result, there we go. We're just gonna run the state, and you remember that will return will return this structure, and then we can look at the completion type. We only care about accepted or rejected. We can't unstart a quest. We already know that the quest is in started state because otherwise we wouldn't have gotten in here. So there we go. We can say it either succeeded or failed. If either of those happen, we return true because something has happened and our quest has been updated, and we need to say yay or boo based on what happened here.
Failed.
Yeah, we need to record that and play that back to players as loud as possible. And then there's case not accepted. So this is why we're not using a standard DFA, because if you got partway through the quest with your quest log, but not all the way, but you didn't get to a failure state either, then okay, you just did a thing that's part of a quest. We don't really, yeah. I mean, I guess we could come back and say, 5 of 7 objectives complete or something like that if we wanted to. But in this case, just the fact that it's not done is good enough. And otherwise, we return false, saying, yeah, no change. That didn't update the quest at all.
All right.
All right. Oh, this is why that didn't have it on it. This is why. Okay. So actually, I don't care that was on that thing was on there, but I created the wrong thing. I was supposed to create a UActor component. I created UQuest, which is a data asset, which is correct. But originally, when I created this file, I created it as
a UActor.
Yes, a UActor component. So I'm going to have a little quest thing that attaches. Like I said, this should attach to the player controller. And when I said that, I probably should have realized that I was talking about a component. But,
So is there anything that we need? Is there anything that you've said up to this point that might?
No, nothing's actually been incorrect.
Okay.
It's just that I probably should have made this the base of the file, because then that way this stuff, whoops, that's the wrong case. This stuff right here would have been auto-generated for me.
Gotcha.
Instead of me just magicking it into existence like that.
Okay.
But that's it, really.
Okay.
Yeah, nothing's actually changed. It's still fine. All right. And actually, I don't even... So, well, all right, I'll just copy the stuff in. This is the stuff that would have been in there by default. So I'm just going to copy it because I didn't actually have to type this originally. Okay, there we go. That's pretty good. And...
yeah, begin and play to component.
yeah, this is just all stuff that would have been in there if I had auto-created that. So no problem. Right here. All right, so update quests with whatever new thing has happened. All right. Pretty straightforward, and I think we know what we're going to do there. We can explain it when we actually type it. And then the rest of the class is pretty simple stuff too. Right? So this is our master list. We don't need this because we just passed each of our quests every new thing has happened. We never need to review everything. But in case you had like a adventurer's log or something, you have some kind of journal, you can keep it.
Yeah.
It's fine. And it's good for debugging too, because then as we go through, we can see what the quest knows about and what we've actually done. We can compare them in our properties window.
Right.
In the debugging thing we'll do hopefully pretty soon. And then finally, this is just an array of all the quests that we currently know of, including not started, succeeded, and failed quests. Not just quests that are in progress, but any quest.
All of them.
Yeah, just all of them. Okay. Let's come over here.
I think that's
Did
everything.
I not put in the code? Well, there's obviously code that I think I didn't put into this document.
What?
That's a bit of an oversight. Yeah. All right. Let's.
Well, now we need to figure out which one of those is the right one.
Now we should probably figure that out. Yes,
Yeah.
that would be a good idea. So let's see.
We're just on the other screen right now, digging through where he potentially put this project file.
Yep. Well, actually, let's do it this way. All right. So this is the C one, which I think might not be right. Try the one that was right next to us. Let me try the last one.
We're just opening up like 4 other projects.
Fortunately, we also have it zipped up, so. Why did it open that file?
Let's see what we got here.
Not that one.
Nope, no quests in there.
Oh, whoops, that's not the right thing to open. Let's see. This is the thing.
Oh, we got some quests.
There we go.
Here.
Yeah, and the beginnings of that, which I didn't. Yeah, so I did call it. Yeah, did I call that structure quest status? I think I did, right? That was the. Yeah.
Yep.
Yeah. See, that was what I originally named that. Okay. No problem. So we'll just take this over. And this stuff that I'm going to copy over here, this is all the boilerplate code that I didn't modify at all. So.
And since we've opened up 2 new instances of Visual Studio, it's going through and indexing everything again.
Yeah. Well, whatever. I mean, it's working. All right. So this stuff right here, don't worry about it. This is the boilerplate stuff. I haven't touched it. Actually, I probably could have just not declared those and then not copied in these bodies either because I didn't change them at all.
Right.
Update quest is actually a pretty simple function. But it's good just to have it here so I know it's typed correctly. Okay. So, anytime we get a quest activity in, we add that to our master log.
Okay.
Then we go through every quest we know about, attempt to update it with this, and then I just have a little log output here. It's pretty straightforward. It prints out the quest's name, so it's convenient that we have that field. And then it prints out either success or failure based on whether or not you got the succeeded code. I mean, technically I should be checking if you have the actual failure code or not, but there's no other way to get true and not have succeeded than to have fail. So we're fine.
Now let's see if
I mean, yeah, it's so, as you can see, it's really simple. Like, this function is basically a for loop. And like I said, this line right here, not really needed. If you don't care about logging everything you've ever done, you can just not have that.
Oh.
No, hold on. Oh, did I forget an include file or something? Yeah, it doesn't know what that is. So what that generally means is you forgot to include this. Probably should tell it what that is.
Do you also need to include actor component?
Oh yes, right, because I.
Yeah, because you.
Right, because that would have been in there by default, and apparently it just knew about data asset without me needing to tell it. Let's see if it knows about actor component by default.
This will be interesting.
It might not actually need that include file, or maybe it does. Whoa! I didn't want to open. Didn't want to open that. There we go.
Yeah, this is kind of weird, isn't it?
Yeah, I guess just the
Since data assets can be used on actor components know about data assets. I don't know.
no. Well, I'm guessing that maybe this is included in some sort of like minimal engine. It's just like an engine.h thing. Like
Gotcha.
maybe it's base class enough that it's in there.
All right, looks like we got
Still failing. What are we
one
doing?
more error.
Oh, cannot open file smstate.h. That's definitely not what I expected to see there. Why don't you know what SM?
No file or directory. That's not true.
No, it's not. I could just run this, but that's So it looked like this over there. I'm actually kind of baffled by that one, because it should know what SM state is. Oh, do I have that on? There we go. So the moral of the story is, even if you run it an hour before, meh, that's programming.
So many steps and so many things that could potentially be dropped.
Yeah, no, it really doesn't know what I'm talking about.
Which is super odd.
Yeah.
Because you got your request generated, that's all over there.
Let's see, was there something else that I included in the CPP file that I, come on.
Wrong, wrong CCP file.
Oh yeah, yeah, that does look very different. Thank you. Come on, up to the top.
Nope,
Wow.
That's basically the same.
I really don't know what to say there. It's identical. This file is identical to that file.
You know, things that are different in the name of your CCP and your age.
Yeah. Quest.h, plugin development.h. I might just run this. I could track this down, but I think maybe I should just run this one.
Yeah, see what happens. But you're not going to have all your...
I will, though.
Oh,
you
have all that stuff.
I remade all of it. Like, I really did the whole thing.
All right.
When nobody was looking. And then when everyone was looking, I did the thing and it didn't work. Because that's how programming is.
Also, since you don't have to talk about it while you're doing it, it goes a lot quicker, I suppose.
Aside from that, I didn't, I named the file after a different thing. I'm just so confused. I mean...
No, I'm looking at it too. It's the same.
All right, nobody else is looking at it though, so let's put it over here. Totally works. Thumbs up. Okay.
Well, we'll make the good one available for
yeah.
everybody.
I mean, that's the one that's gonna be downloaded, and I don't know. Aside from that, I named the thing differently. That I made one class instead of the other class, which shouldn't have any effect on anything. Certainly shouldn't affect whether or not it knows about an H file.
Right.
I don't know. All right, so everything's exactly as we had before, except that Night Quest has been created. So,
well, let's look at NightQuest.
Oh, and the thing won't say about the slapping anymore. It'll just say that he's become hostile somehow. Boo. We'll have to fix that before we send that out. We can't send it out without it.
It's got to have the slapping.
Capital letters. All right, so so we just created a new uQuest data asset, just new miscellaneous data asset.
Yep.
uQuest, pretty straightforward
All
stuff.
the same stuff we've been doing on all the other data assets.
Right. Let's dock this in here. Okay, so the first state. See, and this is why I like to have a name KQ start. So I just.
Yep. This is the start state.
Like really clear. And these are my AnyQuest states here. You can see the full. I don't know if you can read that, but you can see the full path where it says.
Game quests, AnyQuest.
Yeah.
Versus start is specifically the Night Quest.
Right.
So the pathing helps you identify.
Yeah, just in case.
Quest.
Yeah, because like I mean I also put KQ on it, but I mean I could have put like gathered enough stuff, and that could be like 50 different quests. So there's that. Okay. So here are all of the inputs that we care about.
Kill
and
dragon?
This is why, as I was saying earlier, this is why input atom is its own class. Because that way,
so it's not flooded with all these other types of data assets.
Yeah, including literally every other piece of quest data.
Exactly, that would be useless to you in this case.
So there are 5 total, if we count talk to wizard. Only 4 in this list because the wizard isn't part of the quest. So now, what I've also done here, I'm kind of glad this is saving us a little bit of time because we're getting near the end.
Yep.
I made a game mode that just has a new version
pawn.
of default pawn in it. And I just added a little blueprint script for some quick debugging fun. Oh, yeah, I also added a quest status to it.
That's your quest status component that we just made.
It only has 1 quest in it, which is the night quest. That quest has already started. From right in the start of the game, that quest has started. You don't have to talk to the knight first, and the reason is killing the dragon early has to fail that quest. If I kill the dragon and the quest hasn't started, and then I talk to the knight, and that starts the quest doesn't know about the dragon being killed, so I will be stuck in a quest that I can't succeed at until I make the knight hostile or kill him somehow.
Right.
But you can, it's just, the player will have this quest on their books that technically they can never complete, which is very irritating.
Well, it also seems like if you would then need to make sure that you have some amount of logic there to define whether or not you've talked to the knight ever or seen the knight, or else you might have this. Now if you were to just go through and say, hey, what's in my quest log? Hey, what's this kill dragon thing that
presumably
is sitting there?
We would maybe have like the quest in a hidden status, and it would just silently fail and then never come up, like Dark Souls quests where you just don't find an NPC and you don't realize the quest you missed out on.
Yes, exactly.
You just don't know.
I'm just pointing out that we currently do not handle that. If we were to parse our log, we would come up with a started quest that we haven't actually started.
Or presumably someone would tell you, maybe someone in another town tells you there's a knight who wants this dragon to die, and then that's the actual start of the quest.
Right.
But make sure you talk to the knight. Don't just go kill the dragon for him, because then he won't pay you.
He won't pay you. He's a jerk.
All right, so here's the thing that I said I did in alphabetical order. The keys 1, 2, 3, 4, and 5. They do quest activities in alphabetical order. 1, kills the dragon. 2, the knight becomes hostile. 3, the knight dies. 4, talk to the knight. 5, talk to the wizard.
Okay.
So these are just keys that you just press and they'll make the quest things happen. It's just for debugging.
So if you wanted to complete the quest successfully in this case, it'd be 414.
Yes, 414 is how you complete the quest. All right, now let's find us. We're in here, and let's find our quest status.
Okay.
All right, so we know about 1 quest. It is the knight's quest, and it has started. Now, just to show this, if the knight's quest hasn't started, let's say we go talk to the knight.
With 4.
Which is 4. Talk to the wizard, which is 5. So, sorry, I wasn't in the game there. There we go. So now, come back out, and you see we've talked to the knight and we've talked to the wizard.
Okay.
Those are in our master quest log. In this quest, there's still nothing, because the quest hadn't started, so it doesn't care. Okay, so now let's start the quest. All right, now let's talk to the wizard again. All right, great, we've talked to the wizard twice. Why did that not show up on our quest log? Because it wasn't in the input alphabet.
Right.
We don't care. Talk to the knight, though.
Uh-oh.
Uh-oh, so now this is getting a little lengthy, but
we now have
talk to knight.
Okay.
And then just slap him right in the face. All right, good. We slapped him in the face.
Knight has become hostile. Completed fail.
Right. Now, I probably should have brought the log screen up and cleared it first. So let's play again. And actually, we can just, to play again, we can actually just write in here.
You can just trash the...
Yeah, we can just trash this
and restart it. All right, perfect.
Started.
That's great.
Okay. So, yeah, I mean, we could also just close and reopen, but whatever. This is
fun little feature.
Yeah. Because it's just a state machine, right? It has no, like, that's like the definition of state machine, that it has no memory of what's going on. It just knows where it is now and what its current input is. It's like, maybe like kind of an insect, like just the dumbest thing possible. That's just like, no, I just do this right now. That's it. I don't know anything of the world beyond this.
Right.
All right, so let's see. So 4, 1, 4. There we go.
With success.
Dragon slaying quest is complete right there. Let's start over again. Whoops, I just cleared my quest list. That was not what I meant to do.
No, you're going to have to restart. I guess.
I mean, yeah,
Or you could just be like, whatever.
This is pretty flexible. This real-time editing is pretty cool. I did just collapse all my lists, but okay, let's talk to the wizard just so we can expand our lists again. Oh, right, wizard doesn't affect anything. Talk to the knight. Okay, here we go. Talk to the knight. Oh, and let's clear the log because we already have that. Then I don't know. What do we want to do?
Kill the knight.
Let's talk to the knight again. Let's kill the dragon. And then, oops, the knight died. So we still fail the quest, as you can see. It still fails over here. And then I think one other interesting thing to do with this quest is to show that I killed a dragon. Immediate fail. Immediate failure. So so that's our pretty simple RPG quest thing as a state machine. You see how quickly that wrapped up though. Like,
right.
Once we had the bulk of the state machine written, and had tripped over 50 compile bugs. Aside from that last compile bug that we just didn't resolve, we'll figure that out offline because that's. I like that it's realistic that you see the like what? Why doesn't this work?
Yeah.
But I don't want you to watch the full length of that. Let's just assume that words are said.
Yep.
And
Magic
the tables
happens,
are flipped.
And
Flipsed. That would not pass the is this in the dictionary machine.
Nope.
So.
And also, I think Lauren is currently scowling at us if she's listening.
Probably, but she likes to flipsy a table every once in a while.
So let's go look at our question log here, see if we got anything in from anybody.
Whoops. Nope, that's not the right button.
The one that's already open.
This is the
other one.
Button? Why? What's going on there?
Okay. What? Oh, geez. Holy
yes,
Moses.
I thought that might get some questions. Okay, so let me just. This one just happened to catch my eye, so I will do this very quickly. Can I go over the state machine _ API exporting thing again? Yes. Pretty easy to go over that. So is this the one we're running? No, this is not the right one.
It should be on the main screen.
This one, right? Yeah.
Yeah.
Okay. I mean, not that I really need the visual here, but yeah. So the API thing, H file, please. Yeah.
Down.
Okay. So this thing, or you asked about state machine, but whatever, it's the same thing. This little tag. So what this basically means is that this gets exposed so that other modules can see it.
Mm-hmm.
If I don't put this here, it'll be an internal class that other things don't know about, which I might do for some sort of maybe like internal memory management thing that there's no reason to ever change or something like that. But yeah, basically, I don't really worry too much about this tag, but the reason I had to worry about it today was because I put multiple, because by default, Unreal just puts this on when you make a new class.
Right.
But because I had, the state and the branch and all that stuff, it was all in the same H file.
Mm-hmm.
I had to remember or be reminded to put that on there so that way you could do things like, oh, by the way, I didn't show you that you can do this, but you actually can. When you make a new data asset, branch actually does show up.
Mm-hmm.
I mean, there's no reason to do that. But yeah, so that this and this and this would show up.
I
did that. And then quest is from our own module, which, doesn't really.
Right, but if, let's say, for example, you wanted to make this blueprint extendable, right, you would want your branches for your super special blueprint, whatever, whatever reason, it could exist there, and you need that API call or the state machine or whatever API bit in there.
Yeah. I mean,
all right. Well, no, let's not hit in the middle here.
Let's not do that. Okay.
So we've done the first two.
We did that.
What are plugins normally used for?
Good. What are plugins normally used for? Okay, so here's an example of where you use a plugin. Let's suppose that you were making multiple games, and maybe next time we do this, we'll go over using it to read fighting game input, and we can just do that and not have to do the whole setup.
Yeah, exactly.
So let's say you're making multiple games within the same company, and you have some really useful thing that you want to be in your games, but that not all games need. Again, my favorite is Paper 2D. Not all games need Paper 2D. You don't really need animated sprite flip books in every game you make. But if you want some, here's some functionality for it, and you can have it. So then the next question is, all right, so why don't you just write that in your game?
Right.
Because you can just copy the CPP source code and the H files out, and you can merge it over to another game. It's not that difficult. Well, here are a couple reasons why. One, if it's in a plugin, you're sure it's not dependent on anything specific in your game because it can't be. So that's really helpful. Two, our marketplace, you can put plugins up on our marketplace.
Yep, you can sell it.
Which means you can sell it, and that's a pretty convenient avenue, and that installs to the engine, which is cool. So it appears on the plugin list and everything. Which, by the way, ours does too.
If we go into our plugins, there's our state machine.
There's our thing, and then we could, like, here's that stuff that we were filling out earlier. We didn't fill it out in this version, but, we could put our company name and our URL and all that kind of stuff. Okay, so you can do that. Also, if you have a company, like a larger company that has several projects going on, like when I worked at Ubisoft, we do this all the time. There would be someone that comes up with a piece of generic tech, and then that tech can be shared by other projects because it's just this little drop-in thing that you can take if you want or not.
Yep.
And it's easy to take this and it's easier to get this into your project than to get straight C, PP, and H files. Those aren't that hard to do, but this is just way easier. You just take it and dump it right in and it's done. And then the other thing is, if they make an update to that, every project can just grab that update and be assured that unless they wrote it wrong, it'll work.
Yep.
So there are a lot of reasons why you might do that. Will C++ objects link against all engine plugins by default if they're not all explicitly disabled? Well, I mean, we have an enabled checkbox, so if that's set, then it's enabled. I think that answers that question.
C++ project link against all engine plugins by default if they're not explicitly disabled.
I mean, I think the word explicitly kind of throws that off a bit.
Wouldn't that?
There also, the other thing is that your build.cs file has to include the modules as well. So, like, if I try to do...
I think somebody was highlighting... I think Lauren is trying to send us a message.
I don't know. It's hard to interpret.
There's this thing that keeps popping up on our screen in our shared Google Docs here. Add plugin dependency to build.css is what she's saying.
Okay.
Apparently there's some other highlighted stuff that says looky here as well. So I guess I have no idea exactly what she's trying to say. For your compile error...
Yeah, I think that's what
Oh, is this for our compile? Yeah. This is for our literal compile error that we thought was a .h file?
That's weird because I thought that we did do that, but
no, we never dumped in. Remember, we haven't been able to don't open it in there.
I'm not gonna
don't open it in there.
That's right, because when I tried to go in there, it crashed.
It crashed. That's why we've never returned to it.
Although I think well, anyway. Yeah, it crashed, so I'm not going to mess with that. Although well, whatever. Okay.
But that would make sense in this case. It's not going. The question is,
that's where I expected it to be. But it crashed.
Google Doc charades.
She's still here in spirit.
She's still here in spirit.
It's good.
Question. I'm not sure if we specifically answered that. We'll get back to you on the forums in that case.
Yeah.
Once I can figure out exactly what's going on here.
Yeah, I don't know why. I mean, I still don't know why Visual Studio crashed on that. I'm just assuming the C# parser isn't in or something. I don't know. All right. So will this plugin be desktop only?
No.
No. This plugin. I mean, the project was desktop only, but remember that the plugin can just be pulled right out of the project, and it's fine.
Right. And in this specific case, we're not actually using any platform-specific functionality, right? So this could go on Android. I mean, there's no reason this couldn't go on Android. There's no reason this couldn't go on PS4.
No, it's just a couple of C++ classes.
We're not doing anything crazy like using PS4 specific rendering tech or whatever, right? So this would be fine.
Yeah. This could go anywhere.
Now, arguably, you could probably create a plugin that was platform specific. Like if you were,
I think we have some of those actually. I think we have some for like compilation on Xbox One or something like that. I think we have a couple things like that.
Yeah.
Will plugins be able to add override config file entries anytime soon? I don't see why they wouldn't be able to. In fact, I believe they already do. Paper 2D has some configurable settings. Love Paper 2D. So I have to stop saying that, or Michael Nolan is going to think that I'm just like rooting around in his trash at night. I don't know, but I'm really happy with what he did. So
where's the more Paper 2D stuff, man?
So let me see. So we did that one. I'm using data assets so they can avoid creating an editor module. No, I'm using data asset because data asset was, well, because
Convenient.
I wanted an asset that was just going to hold a simple piece of data.
I mean, that's because that's all we're using. Like
Yeah.
we're processing data using the Quest.
Yeah, and it's also
Really.
this is
So-
also deliberately like a code-centric way to do things.
Right.
So it made the most sense to do it that way. I didn't really have any need to extend the editor and make a special like blueprint editor for this. It's just, yeah, it didn't seem.
Yeah, I mean, we talked about doing that before, and yeah. Oh man, you're gonna do a state machine. We should totally get into Slate. And oh wait, yeah, let's stay away from Slate for the time being, if that'd be okay.
So this is a good one. What if I want my state machine to tick and change state after time equals X? Okay, so so state machines don't do that, right? State machines say whether or not a certain set of input is accepted, right? That's what they do. So, but if you had something like, okay, well, look, the night dies if you've been playing the game for 3 hours. Like that's how long you have to complete this the dragon quest.
The dragon
To become the dragon warrior. I also these are all taken. What am I supposed to do? I can't call it King's Quest. I had to just make him a knight. I had to demote him. So yeah, so what if you want your state machine to have a time-based event? Okay, so what we would do is we'd have the Knight's Quest start, and we would have an event saying 3 hours have passed. Or in our case, just the Knight died event could be fired by the game at the 3 hours have passed time. And then that should pretty neatly handle it, because anytime the quest is running, if the Knight dies and you haven't finished the quest yet,
Yeah.
the quest is still running.
I mean, you can just abstract that out to any timer right at that point.
And then if there's some other thing, like you talk to the person who tells you about the Knight, maybe you don't put the quest in your book if you know the Knight's already dead, or you just don't have the peasant say the thing to you, right? I mean, you solve that outside of the state machine is basically what I'm getting at.
Right. Like this isn't a
but you
a holistic system. This is a state machine, and we applied it to a specific concept of a quest. I mean, we could apply it again to fighting games or whatever, but at the end of the day, it's like, well, I need a timed quest now. Well, you kind of you need to handle that as its own thing as a quest, and the state machine still just tracks your quest.
Right, and you can pop an input atom into the quest log that
Knight's dead at 3
indicates
hours.
that has happened.
Done.
So that's kind of how you would do that with that. Okay, so seems artificial. In any RPG, you might have like spells and NPCs, and they need to know about each other. Right, you would not make a core game specific, game core system of the game.
Right.
You would not put that in a plugin. Like the concept of NPCs, I would not suggest you do that in a plugin. Like I'm not going to be sharing NPCs across different games, because what an NPC does in Dark Souls is not the same thing as what an NPC does in Skyrim. Like it's not the same game, so they have totally different behaviors, and even though those two games are sort of in the same genre, even like they're just not. I wouldn't make that a plugin. Same thing with spells. Like spells do something in your game, but what your game, what Ninja Gaiden thinks a spell is, and what Quest for Glory thinks a spell is, those are totally not the same. If I were making those two games, I would not try to have a shared spell module. Final Fantasy something and Final Fantasy something +1 will have totally different spell mechanics.
Final Fantasy N and N +1.
Yeah, like I wouldn't share that. So yes, you're right. That would not be a good use for plugins. Not every tool is right for every job, and that's putting systems that are really specific to your game in a plugin doesn't make sense. Putting state machines in a plugin does make sense, because that's an abstract, like computer science concept that applies to computer science in general, not even just video games.
Yeah, that's why you see a lot of our classes are like that as well. Like they're essential, but they're not game specific. Character movement component, for example, right?
Yeah. And even that, like if your character crawls, like if you're doing a Metal Gear game, you might not use that component, because that assumes your character stands upright.
Yeah, because we only have we have the custom movement states, but we only assume standing and crouching. Right.
Yeah, so if you're making Doom, you could do that.
Yeah.
If you're making Doom in the Unreal Engine, seems bizarre, but
how many game references have we had this time?
I'm I'm trying to jump
4 or
around
5.
here.
Yeah.
I mean, Doom, Halo, Unreal
6,
Tournament, those all
7.
use the same kind of character, right? But like Metal Gear, no, you're gonna crawl. So you don't. You would use your own movement component for that, you would do something different from character, your own inherited pawn class.
Right.
Okay.
So I
That's
can answer that one. How to visualize a state machine states tree. So how you would visualize it is you write a lot of code and you learn Slate.
Wow, I should answer that.
I mean,
that's a good one.
I mean that's just it's kind of harsh to say that way, but it's just there to do it in a visual fashion. There's a lot of UI work that needs to be done.
Yeah, I mean honestly,
and we talked about this. We were like, dude, can't you just piggyback on top of like the state machine stuff we already have written in Slate for animation blueprints? And we looked at it and we said, no,
it's a little complicated.
Lord, no, please no.
Really, for state machines, I personally would be happy with debug outputs. Like you just turn on a checkbox somewhere over here, like in your quest. You turn on a checkbox that says, just log everything. Just tell me about everything, and then you run some simulated input through and see what comes out. State machines are pretty. You want to know what state it's going off the rails because you missed an input. That's fine. You just do that.
Yeah. It just comes down to a lot of work.
Let's get one more.
Well, I think no, we only have one page worth here.
Yeah, I think we have one more good one here, because some of these that we've already answered aren't turned off yet. I think we're good with this one. All right, so how will you call a function of event when the state machine enters, updates, leaves state? I think that's meant to be or. The state machine can only update. Oh, okay, yeah. So the state machine isn't something that's constantly running. Think about the state machine as like a validator, right? So you're going to give me a sheet of paper with a bunch of stuff written on it, and I'm going to say, yeah, this is good, or like, no, this is bad, or this is incomplete.
Or like you saw with our state machine, I'm going to write something on a piece of paper, hand it to you, and you're going to be like, okay, yeah, that's fine. And then I take that piece of paper back and write something else on it. You're going to be like, yeah, that's fine too. And finally, I'm going to get to the point where it's like, finally, I killed the dragon and I'm re-talking to the knight. I've written 2 more things on there. And you come back and you say, yep, okay, you win.
Yeah.
So it's more like a teacher checking a quiz rather than somebody hovering over your shoulders, checking out what you're writing and being like, no, that's wrong.
Yeah. So, yeah, right. It's a one-time check thing that, and we do it every time your update has changed, but we could just check that update on tick, right? We could do that. We add
if we just want to totally eat performance.
Right. Yeah. We could add the input the input atoms, and not check it there, and then just on the components tick just check. But yeah, like Ian's saying, that's a total waste. And imagine if we had like a World of Warcraft size MMO with like 1,000 quests, and every single frame you're checking the progress on every single quest. You really don't want to do that.
And then you're checking whether or not they're started or not started or complete or you're checking everything.
And even then, we do have the the throttling system where you say only do like 3 steps and then stop, and that would help it. But what would really help it is only checking it when there's a reason to check it. Like only check it when something has changed. Like you check your car's gas while you're driving it, or like when you first get in it.
But you're not constantly thinking about it.
You don't get out of your house to go to your car and check to see if there's enough gas. It's just a waste of time. So just think of it that way. Like think of it as a, is the quest over yet? And just sort of, don't ask that question every 5 seconds. That's annoying. But do ask it every time something has changed. So that's why we coded it that way. And don't think of it as a machine that's constantly running. Think of it as a machine that you slide a piece of paper into, and then something comes out the other side and it says yes or no.
Right. And it looks like we got the question that we had up at the top about linking. The question was actually updated at the bottom. This has to do, I believe, with the build.cs file, as Lauren was screaming at us that we need to include our plugin in our build.cs file, which is why, or some additional portion of it. Hopefully Lauren is typing in chat right now, like, don't listen to those guys.
Yeah, no,
here's what we need to do.
That's correct, but I think when it started crashing Visual Studio.
Right.
It was
we kind of stopped at that point because the build.cs files were being weird.
I'm just curious because I'm such a glutton for punishment.
Yeah, you're gonna try to load it again.
I'm gonna try to load it again, and I mean it doesn't matter because we're basically done the stream anyway. But why not end on Visual Studio crashing through no fault of our own? Just for fun.
Are you sure? Because it seems like we haven't.
That sounds like a great ending.
Because it sounds. Well, I'm just saying no fault of our own. Let's be clear here. We apparently haven't installed.
Is this no? Don't do that way. Where are we? There it is.
Yeah, it's plugin development build.cs. Yep, there it is. An exception has been encountered.
I'm trying to look behind it to see if it's in there. I can't see it. I can only see these these modules. Oh, come on. Okay. All right.
And
well,
now we're gonna have it re-index over here. So we'll actually call it good here. I didn't see any notes from Alexander about Thursday's stream, so I have nothing for you on there. I think next stream is going to be. Oh man, I just got asked this question, and I believe next training stream will be me and Alexander.
Oh, cool.
Yes, it'll be me and Alexander for next Tuesday. Tuesday after that will be hopefully DevRel technical artist, Zach, Alan, somebody along those lines. So.
Okay. And we'll probably revisit this with something more for fighting games just to show another application of it.
Yeah.
For a less than 2.5 hour stream.
That would be fantastic.
All right,
guys, take it easy. We're up.